Maths grade 12 math grade 12 2017, paper 2, November memo. This is like what we're going through from start to finish on this channel. So obviously if you really do need to get out of me, you can just use this handle and the course platform. You're going to find like the online courses for math and all that. But anyways, I am not here to waste your time, so let us dive into the questions. Now remember, the big idea with you going through this video is that you actually don't want to just like sit down and like go through it for like all these hours just watching. No. What you actually want to do is you're either gonna just take the whole paper and go through it and then mark and then use the videos to like go through sections that you were, I don't know, not like understanding properly and all that. And then what am I saying? All I'm trying to say is make sure you go through these questions first before you like watch any section. For example, what you could actually do is you can let's say do question 1, finish it, and then use your PDF memo to like mark. And then anything that's not clear, you can always just check in the description for the specific timestamp of that question. For example, if let's say you have done the whole thing, right, and you are looking for, let's say, the explanation for 4.1.2, like it's just a matter of going to your description and then looking for 4.1.2, and then you can just click on it and then it'll automatically take you to the section where I'm explaining this. But anyways, let us begin. Question 1 here says the table below shows the time in seconds rounded off to 1 decimal place taken by 12 athletes to run a 100-meter sprint, and the distance is in meters. It's rounded off to 1 decimal place. So and it says here this is for their best long jump. Wait, what? This is weird. The table below shows the time in seconds, right, to 1 decimal place taken by 12 athletes to run the 100-meter sprint. Oh, okay, there's one to run the 100-meter sprint, and then another one is it says here, and the distance of their best long jump. Okay, so there's one here which shows their times for like a 100-meter sprint, and then here it shows how long they how high they jump. No, how long or how yeah, I mean it's long jump, right? So this basically shows how far they jumped for each athlete. So this is their time taken to sprint, this is their distance when they were doing long jump. But anyways as I'm recording this, like my throat is like kind of killing me, but I think my voice will survive. But anyways, it says here now the scatter plot represents the data above. The scatter plot representing the data above is given. I feel like my reading skills should improve. But yeah, so this scatter plot basically shows us the times for the sprinting here from 10 to, okay, this is just a range, and then from 6 to a 9. That's so that it can accommodate these values here. Anyways, they want us to determine the values of A and B. So the values of A and B here, it's from this formula, and we can get the values of A and B, I mean, from our calculator. We don't need to like struggle, we don't need to like, it's nothing crazy, it's really nothing major. So in your calculator, I'm literally just looking for my calculator now because I'm like, bro, where's the calculator, man? Like wow, I don't wanna lie, like I can't find my calculator. Found it. So in your calculator, right, for you to get your value of A and B, it's just a matter of putting in all this data into your calculator. Now this is what you need to do in your calculator for you to be able to put in all this data. It's quite simple. So on your calculator, right, on your Casio calculator or whichever calculator you're using, you're gonna click here mode. You're gonna click on mode, right, and then you're gonna choose the option that says stat. There we go. And then after choosing the option that says stat, you need to choose the option that shows A plus B x. You see, so after you choose that option, you are going to get 2 columns popping up. So in these 2 columns, you're going to have one that says X, one that says Y. Now, the simple thing is you want to, for example, you see here there is X. This you can have it as your X axis, this you can have it as your Y axis. Now, the big idea is you're just going to put in your data. You can put in all the values for x first and then put in the ones for y afterwards, or you can do it simultaneously. But I think it's neater to just like do the ones for x first. So in your calculator, you see you can put there like 10.1 and then equal to, and then you put the 10.2 going on and on and on. So you're going to fill in all the data here, and then you're going to fill in all the data here for the y, you see. So let me just undo it. Mode stat blah 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 blah. So once you have done all that, right, this is what you then need to do in your calculator for you to get your value of a and b. So after you've put in all your data, right, the next thing that you need to do, you can press the on button, and then from there you can press shift, and then from there you can press the number 1 button. You see, is this number 1 button here? It's written stat at the top, and then from there you'll see there's an option that says reg, you see, for least squares regression line, because that's what this is. So after clicking that option, you're going to see that there's an option for a, and then if you click equal to for the option, so if you choose the option a, right, your value of a there is 14.34. So let's put a here as 14.34. And then obviously you have to just repeat the entire process from the pink part here for you to get b. You see, you just press on again, shift stat reg, and then b, your answer there is negative 0.64, negative 0.64. So these are pretty accurate. Fortunately, we're getting a b value that's a negative, because you see b here almost represents some form of a gradient. So here you can see this is a negative gradient, so that's how we know these are accurate. So that's for question 1.1. You see, nothing crazy, nothing major. 1.2, let's see, it says here, an athlete runs the 100-meter sprint in 11.7 seconds. Use your equation to predict the distance of the best long jump for this athlete. So I mean, this kind of equation is quite straightforward. The big idea here is, you see in your formula, right, you have a value, it's 14.34. your b value, we worked it out to be 0.64. Excuse me. So wherever x and y is, right, it represents you putting in a value for long distance or a value for the 100-meter sprint. So it's more like you're going to use the equation to estimate stuff. So for example, with the person in mind here, right, they told us that this person would have gotten would have run the 100-meter dash in like 11.7 seconds. So remember, for the sprinting, it's x, you see. So you're just going to throw in a value for x here as 11.7. What am I doing here? You're going to put in your value for x as 11.7, and then you're going to see what that brings out in the calculator. So in the calculator, let us see, we are getting there 6.85, and then that's your estimate there. You see, nothing crazy. You're going to get your 2 marks just by writing all this out here. Let us move on. So yeah, excuse me, as I said, man, like my throat, don't worry, the boy does not have COVID-19. COVID-19. No, I'm fine, like totally. Ooh, but anyways, it says here, I shouldn't have made a joke of that, eh? Hey, guys, I'm sorry, yo. Another athlete completes the 100-meter sprint in 12.3 seconds, and the distance of his best jump is 7.6 meters. If this is included in the data, will the gradient of the least squares regression line increase or decrease? Motivate your answer without any further calculations. So the easiest thing you can do for yourself is put this piece of data in your scatter plot and see where that point would be. That way you'll be able to see how it would affect your line of best fit, because remember, your line of best fit has to work according to the values on your scatter plot. So here we can see that the sprinting would be 12.3. So 12.3 would be like, let's see here, 12.123. 12.3 would be in this somewhere here, right? And then let's see here, 7.6 meters. So 7.6 would be like 7.5 is here, 7.6 is there, 7.789. Okay, so 7.6 is like somewhere there. So somewhere here is where our, what you may call, this is where our point would be, right? This point here would be, as we saw here, this would be 12.3, and then here this would be like 7.6. So I mean, like, if you look at it nicely, I mean, like, this one is a bit, you know, straightforward, because I mean, judging from what we can see, our gradient looks like this, right? If you had that point in the data, your line of best fit would need to somewhat adjust a bit. So your line of best fit would look almost something like that, you see, to accommodate this value up there. So we can see that in terms of the gradient, I mean, like, if this portion goes higher, you know, like this, then technically the steepness of your line is getting it's getting smaller and it's getting less steep, you know, because I mean, like, if it were to go down, then it's like more steep, you know, but now it's like something like this, so it's like less steep. So here we can say that the gradient, let's say here, gradient would increase. So the reason we're saying gradient would increase is because, remember, a gradient like this is a gradient of 0. The moment it's like that, then your gradient is a positive number. The moment it's like this, your gradient is a negative number. So I mean, like, if you look at it nicely, the way your gradient is now, it's already a negative value. But then if your gradient becomes something like this, you see the gradient has increased because the value of your gradient is getting higher and higher until it's like a 0. And then from a 0, if it keeps increasing, then it's going to be like a positive value going up, you see. So we have said here, gradient would increase. They said here we should do what? This, if this is included in the data, with the gradient of the least squares regression line increase. So we said increase, gradient would increase. So let's give a reason why here. Gradient would increase because the point 12 coordinate, because the point this is higher. Wait, we need to craft something that makes sense here. Like, I feel like I should actually pause nicely and, like, actually, you know, what you call, think of like something proper, you know, like something proper. So I mean, like, yeah, this does lie a bit higher than the current data. That's what I was saying, and that's what I was about to say. Gradient would increase because the point that is higher compared to the current data. You see, I mean, so that's like not even super crazy or anything like that. So the big idea here is, I mean, we're literally almost home free, you know, we're literally almost home free, because the next question, oh, we are home free, we're done with this question, so we can move on to question number 2 now. Question number 2. Anyway, so it says here, in an experiment, a group of 23 girls were represented with a page containing 30 colored rectangles. Okay. And then it says here they were asked the name of the colors of the rectangles correctly. What? They were asked to name the colors of the rectangles correctly as quickly as possible. The time in seconds taken by each of the girls is given in the table below. Okay. This sounds pretty straightforward. forward-ish. So you have 23 people, right? They were asked to name the colors of certain rectangles, and then the time taken to name all of them was recorded. So these are the times. The first thing for 1 mark, no, 2, is asking for the mean. But for questions like these, right, you may want to get an overview of the kinds of questions that they're asking. Or actually, forget getting an overview of the kinds of questions. For example, the moment they're going to ask for the mean, right, what you want to do is use your calculator. But what I mean is, don't like put all these together, like add them up and then divide by how many they are. You can do that, but I mean, you want to put this data in your calculator so that you can eventually be able to get other things as well. Like if you ever need the standard deviation, and you see here the interquartile range. So because you're going to need other information from your data, you might as well just put this data into your calculator first. So to put this data into your calculator first, well, obviously if you have done what you would have done in the what you call from the previous question, it actually doesn't matter. You don't have to like clear your calculator. You can, but you actually don't have to. So here you can just press mode and then stat. So here you want to press the mode, and then you want to press stat, and then this time around you're going to choose option 1, which says var. You want to choose var. So after choosing var, you're going to see that a table comes out. You see, so this table just has x, and then it has like, just a column here, one single column. So obviously in this table you're going to put in all this data. You see 12, 13, going on and on and on and on and on. You see, you're going to put in all that data. So let's just do that. Let's see here. 12, 13, going on and on. So anyways, so after putting in all the data, you are just going to press the on button. So you're going to press on here, and then to access your data, you're going to press the following. You're going to press shift and then stat, which is the number 1 button, remember. So you're going to press here shift and then the number 1 button. It says there stat, so it says here stat. There you are, go. Now from here you're going to press, let's see here, you've pressed stat, so shift 1, and then on stat you obviously now can get stuff from your information. So here you're going to press var. Why am I yawning in the middle of the day? So you're going to press var there, and then for you to access the mean, it's option number 2, this one here that looks like this, and then your calculator. Let's see what it's going to give us here from the data that we put in. It is going to give us 20.52. You see, and 20.52 is literally all these added up and then divided by 2. So in terms of you showing a calculation though, you may want to just obviously after doing this is going to help you for like other questions, you see. But then for this 2 mark question, the calculation they want is you having to have added up all these. So adding up all these, it would give you 472 in your calculator, and then divide by 23 numbers, you see. And then here you would get this 20.52. So us doing all this, it's so that we can save time, and we can even double check your answer here from having to have done it like this. So in our next question here, the interquartile range, remember the interquartile range is just Q3 minus Q1. You see, that's your interquartile range. This is going to be the interquartile range. Now, luckily, you have to think to yourself, okay, fine, how do you get the interquartile range? So the interesting thing is that you can actually get the the Q1 and the Q3, you can get that from your data, So in your data, you want to go through the following. So amongst your data, right, you know that you have 23 numbers. So for you to find the position of Q1 and Q3, This is all you do. You see, for you to find the position of these numbers, let's say here position of Q1. So to get the position of Q1, you're gonna say 1 over 4 and then n plus 1, like that. So this formula here is mainly going to give you the position of Q1. You see, it's specifically going to give you just the position of Q1 so that you can like count your numbers until you end up at Q1. So here the n represents how many numbers you have, you see. So let's see, in our calculator, a quarter multiplied by 24, that's going to give you 6. So Q1 is in position number 6. So let's count here, 1 2 3 4 5 6. You see, this is where Q1 is. And then for Q3 we basically do the exact same thing. For Q3 though, it's going to be 3 over 4. So let's say here position, here now this is too much, position of Q3, it's going to be 3 over 4, and then this is like n plus 1, you see. So the position here, let's see what that is in our calculator, you know. So the position of that is at position number 18, you see, position number 18. So you're going to count until you reach 18. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, you see. So this is where Q3 is, you see. Q1 Q3, it's just a coincidence that they're like that. It's purely coincidence. So here we can then say, therefore the interquartile range is gonna be 18 minus no bro, come on man, 24. Yes man, come on. After doing all this, now you want to flop at the end. Come on, nah fam. So this is 24 minus 16, right? 24 minus 16, and then let's see what the calculator gives us. 24 minus 16, this is giving us 8. You see, nothing crazy, nothing major. So it's free marks, you get those free marks and you keep on moving forward, you know, because why not? 2.2 says for 2 marks, the standard deviation of the times taken by the girls is 5.94. How many girls took longer than 1 standard deviation from the mean? How many girls took longer than 1 standard deviation from the mean to name the colors? So a kind of a question like this, right? You have to just work with your mean and your standard deviation. So it says the standard deviation of the times taken by the girls is this much. Okay, how many girls took longer than 1 standard deviation from the mean? So 1 standard deviation from the mean, it basically means your mean plus 1 standard deviation. So you want to get this value, and then you want to ask yourself how many people here took longer than this number, you see. So because that's the mean and the standard deviation. So 1 standard deviation from the mean is the mean, we got it to be 20.52 plus the standard deviation, which is 5.94. So funny enough, I think for this question we didn't have to do all this, but I think this you can always remember to do it for other cases, because here, I mean, if they did not give you the standard deviation, then you would need to work it out. But let's see here. Yo, excuse me, my throat. Yeah, let's see, 20.52 plus 5.94, this is giving you 26.46. 26 point what? 46. Yeah, this is quite a weird number, but okay, it's not so weird, but at least some numbers are above this. So we just have to check how many people took longer than 26.46. So we have, let's see here, 1, 2, 3, 4 people. You see, it's just 4 people that took longer than that, so that's it, you see. So it's gonna be 4 girls. There we go. And you keep moving forward. 2.3 says we need to draw the box and whisker diagram to represent the data of the number line, no, to represent the data on the number line provided in your answer book. Okay, well, we don't have an answer book, so the idea is with your box and whisker diagram, remember you need the 5 number summary. You see, the 5 things you need, it is going to be the minimum if in the data, Q1, Q2, Q3, and then the maximum. So here we already have this data. The minimum value here is 12. The maximum is 36. You see, so it's like 12 here. Maximum is 36. Q1 and Q3 we already have. Q1 is 16. Q3 is 24. So Q1 here is equal to 16. Here this is equal to 24. Q2, I mean, it's always going to be exactly in the middle of your data. So, I mean, you could work it out though. I mean, its position, if you really want its position, you know, you could get it. So, let's put here position of Q2. You're going to put here 2 over 4 and then n plus 1, right? So, this is going to be 2 over 4, 23 plus 1 is going to give you a 12. But let us see if the calculator agrees. Of course it agrees. The position is position number 12. So here you can see if you count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, Q2 is a 20. There you go. So from here you can see the numbers are from 12 to 36. So in terms of your number line, I mean, like your number line could possibly have been going in 1s or 2s. Let's see here. From here, let's make this let's just do a number line here. So this is like, we can make this 12. In the middle here, this could be like 24. No, 12. Yo, wow, dude, come on, bro. Yeah, in the middle could be 24. Right at the end here could be like 36. So in the middle here, this would be 12 plus 6. This would be like 18. This plus 6 would be like 30. And then let's see here. Yo, there's like a gap of like how many here? Is it 6? So it's like, yo, goodness, I have to put 6 things here. Yo, now 1, 2, 3. Yo, let's put 15 in the middle here. Yo, yeah, ne? Why am I making this so? Okay, well, remember, you're gonna have a proper number line. I'm just like, you know, thinking of the fact that I don't have a number line. So 3 more would be like 21. 3 more would be like 27. 3 more would be like 33. But then in the middle here, you see you have 16 and 17. Here you have 19 and 20. But we're not going to show those because it's going to look a bit tacky. So yeah, I'm just drawing a number line, but you already have one on your answer sheet, so it's okay. So here now, this is all you need to do. You need to put lines for each of these. Like for example, minimum is 12, so you're going to put a line there. Maximum is 36, so you're going to put a line there. Q1 is 16, 16 is like somewhere there. Q2 is 20, 20 is like somewhere there. Q3 is 24, 24 is like somewhere there. And then Q1, 2, 3, maximum, minimum. These 3 here, you draw a block around them. And these you do that. And then here you do that. And then voila, you have your box and whisker diagram. So you can even write down these values here. 12, 16, 20, 24, and 36. Fantastic, man. Free marks for this kind of a question. So you write that down. And then you can move on to the next question for 1 mark. 2.4 says, the 5 number summary of the times taken by a group of 23 boys in naming the colors of the rectangles is this. So this is their 5 number summary. And then they said for 1 mark, which of the 2 groups, girls or boys, had the lower median time to correctly name the colors of the rectangles? I mean, like lower median time. I mean, like, wow. Median, that's like Q2. You see, Q2 is the median. So we literally just have to see it. 5 number summary, we already know this is like minimum. This is like maximum. In the middle here you have Q2, you see. So Q2 here is 23.5. Q2 here is like 20. So it's like, hello, I'm like, we can like clearly see which one has the lower median here. It is the Macy's, okay? So here we can safely just say the girls have a lower median. There we go. The girls have a lower median. And then that is it. So for 2 marks here, the first 3 learners who named the colors of all 30 rectangles correctly in the shortest time will receive a prize. How many boys will be among these prize winners? Motivate your answer. Wow. Well, it's a 2-mark question. So they said the first 3 learners, so this is including both girls and boys. So anyways, the ones that did it in the shortest amount of time. So let's see. For the girls, the ones that did it in the shortest amount of time, it's like 12, 13, and 13. For the boys, let's see the boys here. Well, the boys, the ones that did it in the lowest time, like the first one only did it in 15, is it in 15 seconds or what? In 15 something. Because they're just recording their time here. They didn't tell us, oh, it's seconds, So for the girls, the shortest one was 12 seconds. But then for the boys, the shortest one was 15 seconds. So here, it's asking how many boys will be amongst the prize winners. Let's say here's 0 boys. You see 0 boys because the shortest time for the boys is 15 seconds. However, the first 3 girls all took less than 15 seconds. However, can you even see my voice is like weird because it's going down. Time for the boys is 15 seconds. However, the first 3 girls all had shorter times let's just leave it here. However, the first 3 girls all had shorter times. That's good enough because look, the first 3 girls all have less than 15, you see. 12, 13, 13. There we go. So they would get all the 3 prizes because they all have the shortest ones. Anyways, that's that for question 2. We shall move on to question 3. Question number 3. This is what they are asking us. They say here in the diagram, A, B, and C, we have A here, we have B over here, and we have C over there. They have given us coordinates of B, yes, coordinates of C also, and then they say that these are points in the Cartesian plane, and then it says F, which is this point over here, so, and G, where's G? G is over there, so we have A, F, and G, these are equal to each other, and then they say they're on line AC, such that these are equal. Duh. Then it says here E is the x-intercept of AB. E is the x-intercept of AB. Okay, nothing crazy here as it seems. It looks like a normal application. It looks like a normal analytical geometry question. For 4 marks here, they want us to calculate the equation of AC in this format. So calculating the equation of any straight line, depending on how you're going to work it out, I know most people like this format, y minus y1, and then you'll have the m and then x minus x1. So this format is perfect if you have one coordinate that the line passes through and its gradient. So for AC, getting the gradient, it doesn't look like we're going to have to do anything crazy here. We're just going to use the gradient formula, you see. So the gradient here, we're going to take the 1y value there. You're going to subtract the other y value over here. So in your calculator, when you put this mixed fraction, you always need to press the shift button first, you see. So for example, if you're going to put 3.5 in your calculator, you have to press shift and then the fraction button. So you always need to be careful of like stuff like that, you see, because our gradient formula, we are just putting in these values. Let me actually just write down the formula up here. Our gradient, we know it's y2 minus y1, x2 minus x1. That's also on your formula sheet. So in your calculator, as mentioned, you're going to put the fraction and then -4 minus. In brackets, you're going to put the shift fraction button and then the 3 with the half there. You see, don't make the mistake of just writing the fraction button and then putting the 3 next to it. You see, your answer is going to come out wrong. So anyways, all that being said, our gradient here is -3/2. So this brings us down to this format that we mentioned here of a straight line, because anytime you see that your straight line, you have your gradient and you have a coordinate that the line passes through, you can always use this formula. So let's use this point that the line passes through. So we'll name this x1, we'll name that one y1, just for the vibes, for this for this that we're doing. So the gradient here, we said it is -3/2, -3/2 x minus what's x? X1 is 8. And then here y minus 4, so it's going to be +4. Multiplying inside, you have -3/2x, and then this is going to be positive. I think it's going to be positive 24/2, which is like a 12. Of which, when you take the 4 over to the other side, you're going to have -3/2x. 12 minus 4. What is 12 minus 4? 12 minus 4. Come on, man. Yo, my brain was like literally bombing out. Like, nope, I don't want to think today. I shall not think. Leave me alone. Type of thing. But anyways, it is what it is. It's all good. It's all good. No issues, no problemos. Let us carry on with the next question that comes after this. So let's see what we have to do here. The next thing that they're asking us here is the coordinates of G if the equation of BG is this. So anytime you're given the equation of a straight line and it's not in standard form, the one thing that you obviously need to do is to put it in standard form first. Because if you look at BG, BG is just B to G. It's just a straight line. So before we even do anything, I mean, like, we might as well put this into standard form first. It will make your life easier. So putting it into standard form, it means that we have to isolate y. So the 7x goes over to the other side. And then y, we're going to divide here by 10. And then here we also have we're going to have to divide by 10. So in your calculator, this is just going to be in its simplest form, which is just going to be, hey, what's the highest number that can go into both of them? Looks like a 2. Yeah? No, 4. 2, bro. So this is going to be, it's -7/10x. I think this is going to be 4/5. Yeah. Perfect. So we have this equation. They said we should get the coordinates of G. Now, the clear thing is that G is the point where these two straight lines meet, this straight line and this straight line. So, I mean, I don't think it is rocket science here. We are basically going to equate our two equations for us to find out where they meet. So we're literally going to take here equation number 1, which is this one, -3/2x plus 8, right? We're making it equal to -7/10x plus 4/5. Now, with all this being said, right, we need to do the following. So this goes to the right. This is like -3/2x plus 7/10x, you see. And then this to the other side, that's like 4/5 minus 8. And then, hey, gonna have to use our calculator. Where's this calculator now? Oh, snap. I lost this calculator. Oh, there it is. Thank you. So it's like -3/2 plus the 7/10. And then what? This is like -4/5. So it's like -4/5x equal to a 5/4. What's going on here? Yeah, 5/4 minus 8. 5/4. No, 4/5 minus 8. What am I saying? Yeah, -36/5, of which, I mean, here, don't even think of doing anything fancy. Just divide both sides by the number in front of x. It is very much legal for you to do that, you see, so that this cancels that. Most people would not be comfortable doing something like that because they're like, but it's a fraction. You know, what do you do if it's a fraction? If it's a fraction, you do the exact same thing that you would do if it was not a fraction, you see? Why you gotta discriminate against the fractions? Like, that's not on, man. Like, don't be that guy, okay? Don't be that guy. Anyways, this is gonna give us an x value of 9. So for 3 marks, we are moving on to the next question. The coordinates of G if the equation of BG is this. Huh? Oh, dang it. Two of the same thing. We will have to move on here. We'll just have to say, yeah, I should just, dude, I feel like, let's just move on. Let's not waste any time. Anyway, it says here, for 2 marks, right? So show by calculation that the coordinates of A are that. Hi, wait, what did I want to, oh, wait, hold on. We just got X here. We're not even done. Wow, bruh. Wow, we might as well make ourselves space because, hey, we were too jajarach. Now look, we're being humbled. Made to go back. This question is like, go back. Anita, you thought you were done, but nope. You are is not done. You are is not done. But anyways, let me just make some space here so that we can just quickly get the y value. So getting the y value, I mean, like, there's really nothing much to it. You're just gonna use any of these two equations, either the main one up there or this second one here. Both of them will give you the y value of this x value. So here y is gonna be equal to what? What is it gonna be equal to, bro? Come on now. It is going to be equal to I didn't have to do that. -10, -7/10. X is like a 9. And then all this in the calculator. Let's see. -7/10. And then like a 9 there, right? And then plus 4/5. No, oh yeah, what's going on there? 4/5. Oh, fantastic. -11/2. -11/2. That's your y value. So your value of G, therefore, let's just see if it's accurate. Nope, not accurate at all. There's something wrong. Come on, man. We're making a mistake so early. Hey, this is like super duper annoying. Like, when you make mistakes and you're like, why? Like, why? It's so not nice. So I have to double check something here, make sure I didn't make a dumb mistake. Oh, what is this thing here? I think, what happened here? Yeah, so this equation is, let's check the other equation. Well, even though, let me see here, putting this equation into standard form. Let's see. Oh, sure, after doing all this. Well, baga. Well, anyways, I mean, like, what can you do? We can't do anything. We just have to humble ourselves and show that, you know what, mistakes, they'll creep up on you, man. You don't gotta, you have to not act invincible too much. Sometimes you just have to be humble. So here, divided by -10, right? Meaning this would have been a plus, meaning that this would have been a negative. Yeah, that's what messed everything up, This would have been a plus, this would have been a negative. Meaning this would have been a plus, this would have been a negative. Okay, let's get an x value now. Wow. Being humbled is, yeah, something else. But at least, this is also gonna show you the idea that, I mean, like, yeah, if your answers seem a bit off, double check them. And also, yeah, you see here, we didn't even have to overthink it. Here we are getting a y value that's a positive number, so our answer was clearly wrong. So moving on here, let's see, -3/2 minus that number, -3/2 minus the 7/10. What you got? That's like -11/5. -11/5x is equal to -4/5 minus 8. Let's see what that gives us in the calculator. -44/5. -44/5. Yeah, -44/5. What? Well, I mean, from what we did in the first one, I mean, we're going to do exactly the same here. We're going to divide by the fraction in front there. Divide by the fraction in front there. So dividing by the fraction, we're technically getting there. This cancels that. That's like x is equal to, let's see, this divided by negative 11 over 5. Negative 11 over 5. Oh, 4. Ah, that's a nice looking number. So here, if you put a 4 where x is, let us see what the corresponding y value is going to be in the calculator. So according to the calculator, we're going to get a y value of 2. So our g here is just 4 coordinate 2. Like, would you believe it? How nice. How fantastic. Anyways, I mean, when life gives you lemonade, you drink it. Okay, that's dumb. Let's see. For 2 marks, it says, show by calculation that the coordinates of A is 2, coordinate 5. Coordinate of A, where is A? A is up there. Okay, so for A, I mean, like, we're going to use a classic method. And when I say classic method, I literally mean that it's like one thing that you use very often. It's a midpoint formula. So here we know this is for coordinate 2. And we want to find the other side of the spectrum. We want to find the other side of the line. We can label this x1, y1, and we can label this x2, y2. You see, between these two lines, we have the midpoint. So we can use the midpoint formula to find the other side. Like it's literally a technique we can always use, you know? Because remember the midpoint formula, let's see how much space we have here. Not so much, not so much. But with the midpoint formula, remember the idea is it's basically going to show you that the midpoint, whatever the x value and the y value is, right? You will always get it by saying x1 plus x2 over 2, and then y1 plus y2 over 2. So the big idea is this x value here goes with whatever this is, right? And technically, this y value of your midpoint goes with whatever this is. So in our question here, we have the midpoint. We have the x value and the y value. We are just missing x2 and y2. So in our formulas here, we don't have x2, we don't have y2, but we have x1 and y1, you see, of which if you our midpoint is just I keep having to scroll up, it's 3 and 3.5. So the midpoint, you see, we have 3 and 3.5. Let's just be careful what 3.5 is. Might as well use it as an improper fraction and not a mixed fraction. So 3.5 in your calculator, you have to press the shift button first and then the fraction button afterwards, which is going to show you there's 7 over 2. You see, so this is the midpoint. And then for our coordinate, we have G, which we just worked out. So you can see why you don't want to get things wrong, because they spill over into like other questions. So just by looking at this, technically you see this is x, this is y, this is x1, this is y1. So we can just make use of our formulas here. You see, so let's do the pink. For the pink, we already know that x is equal to x1 plus x2 over 2. So our x value here, as we saw, is just a 3. So we have 3 there, equal to what? Equal to what? Maybe x1, which is like a 4, plus x2, which we don't have, over 2. So we're going to get x2 from doing this. And then for the blue, or rather the green, rather. For the green, we know that y is equal to y1 plus y2 over 2. Because, yeah. So the y value of the midpoint there is 7 over 2. What is x1? x1 is a 2 over there. What is y2? y2 is a 2. Hey, I feel like I should, yeah, here we can just solve for x and y now. So solving for x here, we can multiply by 2 on both sides. And then here the 4 goes over. We are done. Is done. Here, the fortunate thing is they both have a denominator of 2. But without overthinking it, we could just cross multiply if you wanted, you know. But we don't have to. We're like, but yeah, you really don't have to. You can just multiply this side by 2, multiply this side by 2. And the denominators fall away, you know. Why you gotta make life difficult for yourself? So from here, getting y2, the 2 is gonna go over. Y2 is a 5. So here, therefore, our coordinate is 2 coordinate 5. Let's just check if that's gonna make sense. Yes, 2 coordinate 5 definitely makes sense as a coordinate of A. So therefore A is just x value 2, y value 5. Whew, I don't know lie, and paper 2 is kind of flow, man. Paper 2 is kind of flow because it's like, yeah. Yeah. I have not gone mad. I am still 100% sane. Prove that EF is parallel to BG. So proving parallel lines, I mean, the first thing you obviously want to think of is like fun, you know. Corresponding angles, cointerior angles, alternating angles. So you want to think of that when you're thinking of EF and BG. Let's see where EF is. There's EF here. Oh, and then there's BG. Ooh, I'm already thinking of like the proportionality theorem. But then why though? That's just so extra, you know? I was just being so extra, bro. Like, dang it, man. Dang it. But anyways, I mean, how many marks is this question? So yeah, me asking how many marks is this question, that's literally like a reflex action. Because I literally was thinking to myself, how much thinking needs to go into this question. So in terms of us proving that these are parallel, I mean, yo, it's gonna be interesting. It's gonna be interesting. Did we? Yeah, I think we're gonna have to use some kind of proportionality theorem here, like legit, because I mean, just look at the way the triangle is. You know, it's literally screaming. Oh, excuse me. Like it's so late. It's so late. But anyways, yeah, this question is literally screaming proportionality theorem. Like I don't want to lie. Like it's literally screaming proportionality theorem, or some kind of yeah. So the one theorem I'm thinking of here is the midpoint theorem. The reason I'm thinking of the midpoint theorem is because with the midpoint theorem, right, it basically states that if you have a third line of, if you have a line inside a triangle, this whole triangle here, this red triangle, right, what we can already see is that the one side here is being cut in half, right? So this other side here also, if we can just show that it is also being cut in half, then we would have proven the midpoint theorem, meaning that we would have proven that this is parallel to that. You see, because this is already equal, so we just need to prove that EB is equal to EA. So let's get E. Getting E is not a problem because we just need the equation of line AB. Do we have the equation of line AB? We don't. But I don't think getting the equation of AB is gonna be a problem because, like, bro, come on. Forget the equation of AB. We just need E, you know. But then the thing now is, how do we show that E is the midpoint of the line AB? You see, that's like another story on its own. You know, I'm like without like overthinking anything. Let's just get that equation of AB so that we can get the coordinate of E, and then as soon as we have the coordinate of E, we'll be able to use it to show that we have this line being equal to this line. Yeah, because if we get the coordinate of E and we show that E is the midpoint of AB, then we would have shown that this line is equal to that one. So let's get E. Getting E, it looks like we just need the coordinates of we just need the equation AB. So let's do it. A here we got 2 coordinate 5. So yeah, let's get line AB. I feel like down here, do I have space? Should I have, because I keep scrolling up and down all the time. It's like, hey, it's so taxing, bruh. Like yo. Let me write out the equation stuff here and then take it down. So y minus y1, and then we have m x minus x1. So the gradient is the first thing we need, right? Which is obviously going to be 5 minus the negative 5 there, which is going to be a plus. 2 minus the 6 there, which is also going to be a plus, and then this is like 10 over 8, which is like 5 over 4. Perfecto. And then what you need now, we need a coordinate. Let's use the 2 and the 5, because like why not, right? So y minus 5, and gradient is like 5 over 4. What else? X1 is like 8. What coordinate are we using now? We're using this one, so it's like minus 2. And then let's just 5 over 4x here. This is going to be 10, negative 10 over 4. What you got? What you got? I forgot to take the 5 to the other side. But it's okay. It's okay. Y is equal to 5 over 4x. And then here you have negative 10 plus the 5. Negative 10 over 4 plus the 5. Negative 10. Oh, hey, calculator. This calculator is like now work. Negative 10 over 4 plus the 5. Yeah, negative 10 over 4, right? And then plus the what, man? Plus the 5. There we go. There we go. That's 5 over what? 5 over 2. And is that a positive? Yep, positive 5 over 2. So that's the equation of line AB. Now you may be thinking to yourself, okay, bro, we got the equation of like line AB. Now what? Now what? Now we just need to show that we just need to get the coordinate of E. So coordinate of E is just the y-intercept, right? E is just the y-intercept. Come on, bro, let's see. E is just the y-intercept. So let's see what you're gonna do. So the y-intercept, it means that the y value here is 0. So 0 is equal to 5 over 4x plus 5 over 2. Before I even carry on, let me just take this down to where I'm supposed to be doing it. Cut. And then we have to go down to down here. Past it. Why you have to make it so big, bro? Come on now. There we go. So we're trying to get the y-intercept here. So getting the x-intercept. Yeah. So getting the x-intercept here, the 5 over 2 can go to the other side. And then here we just have to divide both sides by 5 over 4. So this 5 over 4, and then this here 5 over 4, right? And then from there, we're gonna have x is equal to this divided by that. So it's like negative 5 over 4, negative 5 over 4. No, negative 5 over 2, man. This pink one divided by the yellow one. So let's see, 5 over 4. And then this is like negative 2. So we have negative 2 over there. That's our x value. Perfect. So we now know the coordinate of E. E is just negative 2 coordinate 0. So all we need to do is to prove that E is the midpoint of the line AB by using the midpoint formula. So in the midpoint formula, let's put A and B in there. So in our midpoint formula, right, A is this one. Let's just rewrite it again for the vibes. B is, what is B again? B is negative 6 coordinate negative 5. So we're just going to throw these into the midpoint formula and see if it gives us the coordinate of E. Because if it does, then we would have proven the midpoint theorem. So our midpoint, we know that we would have the midpoint of AB. We know that we are getting it from, how do you do it again? x1 plus x2, brah. x1 plus x2 over 2. And then what's this now? y1 plus y2, y1 plus y2, because plusing a minus gives a minus. So these are going to be the coordinates. Let's see here. You're now, oh no, oh no, oh no, what? Oh no, this is fine. This is negative 2. This is a 0. Perfect, man. You see, therefore E is the midpoint of AB. So we have proven the midpoint theorem. The midpoint theorem clearly states that if a line from one side of a triangle cuts the side in half and also cuts the other side in half, then that line is parallel to the third side of the triangle. So here, that's what we're going to state as our reason to say that these are parallel. So here we can clearly say, therefore, EF is parallel to BG. The reason is midpoint theorem. You see, you have shown that the midpoint theorem is being upheld there. We have shown that we have a line coming from one side of the triangle, inside the triangle, and it's cutting this side in half, and it's also cutting the other side in half. So us showing that it has cut this side in half, we have just shown that this is actually the midpoint, which is point E, by using the midpoint formula. The midpoint formula showed us that this is the midpoint, and then our straight line equation showed us that this is the x-intercept. So we found this coordinate here. We knew whatever this coordinate is, if we can just show that it is the midpoint, then we would be good to go, which is what we did. So I can safely say that there were probably like many ways to have like answered this question, but I guess this one is the one way that we have chosen, and we are moving on, not even wasting any time. But if you have any questions, like, you can just hit me up in the comments, so in the comments, depending on whatever questions you have, it doesn't even have to be math related. You can even ask questions like, how do you not procrastinate or something, and then I'll be able to just give my 2 cents, I guess. It says your ABCD is a parallelogram with D in the first quadrant. Calculate D. Hey, I feel like this question I'm gonna have to like take a screenshot, and then I am going to need to do? I'm gonna need to like crop this out, make this smaller-ish, I think. Hey, let's do down here. Save. Save. Let's go down here, so, and we need to like map out what's going on over here. It says ABCD is a parallelogram with D in the first quadrant. A, B, C, D in the first quadrant. You see, I'm going to put D somewhere here, because if you're going to have a parallelogram, I mean, like, look at this shape. You see, this is we need to be strategic. Let's finish this question. Let's get the gradient here, and then let's go boom. No. I want to think in the line only. There we go. So this line is gonna be somewhere here, right? And then we have what else? We have this here, and then we have this there. See, and then we have this here. Fine. So this is the parallelogram that they're talking about, right? These parallel to this, these parallel to that. And then here they're asking for us to get D. Now, questions like these, right? I mean, like, there's just like a classic way of doing it. Whenever I say something like classic way of doing it, I'm trying to say that it's a common question and there's like a common way of answering the question. So the one way to answer this question is you're going to make use of diagonals of a parallelogram. When I say you're going to make use of diagonals of a parallelogram, I mean, for example, all you need to keep in mind is you're also going to use the midpoint formula here again, you see, because with a question like this one, let me see here, do that, try and make this, all nice and stuff. Kablamo. Okay, there we go. So you have this line here, and then you also have that line over there. Okay, perfect. So the idea is the point where these two lines meet is this point in the middle here. This is the point where this is the point where your two diagonals meet. Now, properties of a parallelogram tell you that this line is equal to this one, and then this one is equal to that one. So for you to get D, you have to use the midpoint formula. Meaning all you have to do is you have B already. So you want to use A and C. You want to use A and C to get the midpoint here. After you get the midpoint here, you can now use A. You'll now be able to use B, the midpoint, to get D. Before we carry on, let's just get the midpoint of AC, because the midpoint of AC is also the midpoint of A, is also the midpoint of B, D. So let's just get it. The midpoint of AC, we're gonna use the midpoint formula, meaning we're gonna have to say 2 plus H, 2 plus 8 over 2, and then 5 plus negative 4 over 2. So this is like 10 over 2, which is like 5. This is like what? 5 minus 4, that's 1. So this is like a half. Kind of makes sense. So the midpoint here is 5 coordinate a half. And then now you need to make use of what we did right in the beginning for that other question, where we're going to say this is the midpoint, right? The x value of the midpoint, and this is like x1, y1. Here you would have technically x2 and y2. Hi, Bowman. Let's draw it a bit better, bro. Draw it a bit better. X2, y2. So, yeah, let's just perform the ritual. So here we said x is equal to x1 plus x2 over 2. That's for the x value of the midpoint, right? So that's the 5 equal to negative 6 over there plus x2 over 2. And then multiplying by 2 on both sides, you'll have 10 here equal to negative 6 plus x2. The x goes over. This is like 16 x2 over there. Perfecto. So you already know that the x value here is what did I say here? 16. Nice, man. Nice. The y value is going to do the exact same thing, you know? You're just going to say here y is equal to x. Hey, y, bro. y1, y. Okay, if you don't get it, forget about it. Yeah. Anyways, so this is like negative 5, ne? Let's see, negative. Whoa, yeah, negative 5 plus y2 there, plus y2 over 2, right? And then zoop. Let's see, what is that now? Hi, Bowman. What do I need? I need I need a half. So this is a half over there. Multiply. So here we can just multiply both sides by a 2, right? And then you'll have negative 5 like that. And then the negative 5 goes over, it becomes a plus. So the y value here is a positive 6. So does this look accurate? Yeah, man, most def, because the distance between the y values here is just 1 up. Here from 5 to 6, that's 1 up. The distance between the x values from negative 6 to from negative 6 to 8, that's 14. And then from 2 to 16, that's also 14. So yeah, man, your coordinate of the letter D there is definitely accurate, you know, definitely accurate. So we shall move on to question number 4, you know, because question number 3 has been real. Anyways, question number 4, another analytical geometry question. Analytical. Okay, so this is where you like really have to bank marks, you know, in these analytical geometry questions. But anyways, let's see what it says here. In the diagram, P, where is P? So as you saw, if you're gonna read anything, just check where it's written. Huh? What? If you're gonna read anything, just check where it's written. If you're gonna read anything, just try and, you know, check it with the sketch. So we read something about P there, and then they told us about K up here. Where's K? K is somewhere there. Okay. And then they said end points of the diameter of a circle. End points of the diameter of a circle. Interesting. And then it says the end points of the diameter of a circle with center M. So there's center M over there. And then it says S and R are are respectively the X and Y intercept. Where is S and R? Oh, okay. Oh, okay. So you have S here, which is the X intercept, R here, which is the Y intercept of the tangent to the circle. So this is also a tangent to the circle. And as long as we know our theorems, we already know that this is a 90-degree angle. Now I'm saying, because yeah, and then it says here, what else? Theta is the angle of inclination. Interesting. And then it says PK. Where is PK? PK, yeah, it's the angle of inclination of PK with the positive axis. Interesting, man. So for 4 marks, we need to get the gradient of SR. Where is SR? Well, SR is an interesting question. SR is from here. Wait, what? We need to get the what? The gradient for 4 marks. Well, I mean, like, anytime you're going to work out the gradient, I mean, it's really not a big deal. Like really, like, hello. So here you could be thinking of the gradient formula. Yeah, that could help us. But fortunately, with these kinds of questions also, they are classic questions. Because look, if you're going to want to use the gradient formula to get this, it's not going to work out directly. You will need to get the gradient of this line first. You see, if you can at least get the gradient of this line here, because you have two coordinates at two ends, you can then use m1 times m2 equal -1 to get the gradient of SR. Because remember, the gradient of one line multiplied by the gradient of a line that it is perpendicular to will always equate to a -1. So that's the law we're going to use. We're going to get the gradient of PK first. So the gradient of PK, we are just going to get it by saying 5 minus the -3 there. And then -4 minus 0. Because remember, we're just using the formula y2 minus y1, x2 minus x1. You see, this is gradient. It's on your formula sheet, so no, I'm like writing it out is really not like a big deal. 5 plus 3, that's a 8. 8 over -4, that's gradient is like a -2. So I mean, like here, as we said, right, the gradient of PK multiplied by the gradient of SR is equal to -1. So here our gradient is just a -2 multiplied by this gradient, we will get a -1. So both sides we have to divide by a -2, and then we shall be fine. SR here, this is giving us a half. That's the gradient of SR, and you'll get 4 marks. You see? So I think the one thing I'm trying to highlight with these past papers is you have to note that there are certain questions that are just standard. You know, you really don't have to like overthink it and crack your brains trying to figure out what they're asking. You know, some of these questions, if you don't know what they're asking, it means you haven't gone through enough past papers. That's why past papers are just like a hack, and it just shows that this whole syllabus in school is like the whole game is rigged, man. So just play the game, you know, just play the game. Don't overthink it. The equation, we need to get the equation of SR. So getting the equation of SR, I mean, we might as well want to start with this, because remember, if you write this out, all it means is you need a gradient and a coordinate that the line passes through for you to get the equation of the line. That's why this is just a 2-mark question, because we have a coordinate that the line passes through. It's P. Wait, what coordinate do we need again? We need SR, and it passes through P. So P, which is just -4 and 5, we are going to label this x1, y1. And then with all that being said, we have y here minus 5. Gradient, we have it as, was it a half? Yeah, it's a half. X. X1 is like a -4, so you have to put a fire positive there. So this is like what? A half x. This is like 4 times a half is like 2. And then you have here 5 minus y minus 5, I mean. So here everything on one side, you have y is equal to a half, and then half x, right, plus what? This is a half x plus 2 plus 5. This is like a half x. What is 2 plus 5? It's a 7. Perfect is good, So with all this being said, right, we need to do the following. What do we need to do? Nothing. We're done. I literally just, it's like, you know, when you solve something by mistake, you're like, yeah, what? We're done. Yeah, we're done. So for 4 marks here, it's like we need the equation of the circle in this format. So getting the equation of a circle in that format is not too bad, because we need the center and the radius, of which getting the center, we can just use the midpoint formula. The radius, we can just use the distance formula. Wow, man, like I feel like this paper was like so easy. Like, yo, It's so scary simple, this paper. Like like yo. So P and K, P, we know it's like what? What is P? Negative 4 and 5. K is like 0 and negative 3. But I guess maybe if these portions are like the easier portions, maybe the other part of the question is like hard, you know? So the midpoint of this gives us the center. So the midpoint of this, we know we can just say this plus that over 2, this plus that over 2. This is like what? Negative 4 divided by 2 is like negative 2. 5 minus 3 is like a 2. So 2 over 2 is a 1. So this is the midpoint, M. So that's going to give us A and B. So here we're going to put a positive 2. Here we're going to put a negative 1. Because remember, when you throw a negative 2 over there, this is going to be a plus 2. When you throw a 1 over there, here it's going to be a minus 1. So nothing crazy. Now we need the radius. Of which the radius is just going to be the distance between n of these points and M. So yeah, our distance, which is our radius, is going to be square root of, let's just say this minus that, squared. And then 5 minus that squared. Because all we're saying is the radius is just the distance between this and M. You know, that's the radius. Because remember, M is just negative 2 coordinate 1. So all we just said here was this minus that, and then 5 minus the 1 there. That's all we did. So here, our distance here, let's see, we're getting like, I don't even know why I'm not just using the calculator, because hey, there's really no point in not using the calculator, you know. There's no point in trying to flex and not using the calculator, because I don't know, maybe you're trying to be like Rambo or whatever. I don't know. And now I've lost my calculator. The same calculator I'm saying you should not use. I mean, I should use. Oh yeah, I said you should use the calculator. I lost it, but I found it. It's down here. Whew, there we go. There we go. Let's see what this is in the calculator. Square root of negative 4 plus 2 squared plus 5 minus 1 squared. This is giving us 2 square root of 5. Fiona. That's the final answer. So let's just say here 2 square root of 5. So that's the radius. So I mean, it's fine. It's fine. When we're done here, all we have to say is x minus, what is the, we said here it's going to be a plus 2 squared. Y minus 1. And then here we have equal to r squared. So here you have to be careful. You can literally just write it like this and then square the whole thing. You don't have to simplify it. You can just leave it like this. I forgot that. But I did remember to put it. So like that is fine. We don't have to overthink anything. Like we can just move on, because life is good, you know. When life is treating you well and you're doing analytical geometry and it's like working out, this is where you must bank your marks, eh? Like don't feel sorry for the paper at these times, you know. Like this is the part where you're like, yeah, it's my 10. You just bank those marks like legit. So here they want us to get the size of PKR. Let's see where PKR is. PKR. So we have to get, let me see what I have to get here. Crop. Let me just crop this out. There's like this. There's like this. There's like this. And then let's save. So with all this being said, right? Let's go down to the bottom and carry on with our question there, because like what's the point of just scrolling up, down, up, down, up, down all the time? I know, man. So with the triangle we're dealing with, and take note of how I'm talking about a triangle here, because normally if you're going to work out angles, just think of which triangle you can use to help you. Because if you don't use a triangle, hey, that's just being arrogant. For nothing, man, for nothing. So luckily we have a right angle triangle here. We have so much information, I think. Do we? We'll see. So what do they want? They want PKR. So PKR is this angle down here. PKR, it's this angle here. So I mean, like, just looking at it now, it's like, yo, what must we do now? It looks like, hey, nah, man. Like, I don't lie to you, ne? I'm yawning. I don't want to lie to you, ne, but it's not very straightforward, this angle. So normally what you want to do in these kinds of situations is you just want to think outside the box. Fortunately, we have this distance here. Remember, radius and radius gives us the what you call, it gives us the diameter. So the radius times 2 is just 4 square root of 5. Let me just do that again. Let me just make this clearer for everybody to see. Our radius is this distance here, you see? No, our diameter, which is double the radius. So double the radius is this value times 2, which is just 4 square root of 5, you see? Now, okay, we have one dimension. What else do we have? We have nothing, man. Like, it's not working out. We have just a dimension there. Like, I don't wanna lie. Like, as I'm looking at this question, it's like I'm blocking. I'm like, my brain is just, it's like blocked. Like, oh, even that's why I yawned now. Like, my brain is like proper blocked. I'm like, what? How do we even get that angle down there? So I'm thinking to myself, okay, how is that theta gonna help us? And this is how that theta is gonna help us. You see here, even though I'm focusing on the big triangle there, it doesn't look like the big triangle is gonna help us. So I might as well forget about the big triangle because the big triangle is too big. Pun intended. No, there's no pun in that. Like, literally, there's 0 pun. I don't even know why I said the pun intended. They're like, yo. So what I'm looking at now is maybe this smaller one. Because this smaller triangle, the reason why this one is probably more helpful is because we have a 90-degree angle here, right? And we have this portion here where we can use vertical opposites to help us. Because if you're looking at your sketch nicely, right? I mean, like, judging from what we can see here, if you can get this angle, you would have this angle also, you see? So let's deal with that triangle there. P, there's O here, there's K down here, and then there's this going on. And then here, you have theta. So you can get theta using the, what you may call, the angle of inclination formula, right? Meaning you can write here tan theta is equal to the gradient of pk. The gradient of pk, we worked it out. It was, I think, negative something, -2, right? Yep, -2. So the idea is, anytime you're gonna get an angle here, regardless of whether this is like a negative, always just use the value on its own to get a reference angle, you see? Because if you use the negative, I mean, like, it's gonna give you a negative number, but then whichever way, here you're just gonna get a reference angle first. Reference angle is equal to shift tan negative, I mean, shift tan 2, which is gonna give you 63 point what? 63.43. Okay, that's your reference angle. So remember, this is literally, if you think of the English definition of what a reference is, a reference allows you to get the actual thing. You know, it's just something to refer to. So what we have gotten here is the reference angle of theta. I mean, like, if you wanted theta specifically, you are just gonna say 180 minus this, because you have to remember, whatever you're getting here, it has everything to do with this line. So the acute angle here is the 63.43. Hey, Bowman, come on. The 63.43. If you wanted the actual theta, you were just going to say 180 minus this value. So this 63.43, I mean, like, it's going to be that angle over there because of vertical opposites. And then now we can work out the what you call the PKR. So this angle here, which is K, or rather PKR as they said, PKR KR. The fortunate thing with analytical geometry is it's not like Euclidean geometry where you have to have like reason statements. No. Whatever you're writing out, just put it on your answer sheet so that it's traceable. So the angle here, we are now just saying 180 degrees minus 90 minus 63.43. And then what is this giving us now? 180 minus 90 minus 63.43, right? This is going to give us 26.57. Yep, that's the angle we're getting. And I mean, like, yeah, why not? That is the angle we're getting. So, I mean, like, there are different ways that we could have gotten this answer, like, depending on whatever it is that you would have done. I mean, you know, different strokes for yo, I don't know, I'm yawning so much, like, yo. But like, as I'm recording this, it's like super late, so it is yammer. Anyways, that was that for that question. Nothing crazy, nothing major. With this next question, right, they said we need to get the equation of the tangent to this circle at K in this format, and it's just a 2-mark question. So I mean, like, the fortunate thing here is this question is just highlighting that a tangent is just a straight line. So for this tangent, we just need our gradient, which we have, and we just need a coordinate that the line passes through. Wait, why are they asking us for the equation of the tangent to the curve when the equation of the tangent to the curve is SR? You see this question? You see? They flopped. They're asking us the exact same question, like literally. They have asked us the same question twice, but it's like, wait, what? Have they? Have they really? Awkward. This is like super awkward, like legit. Calculate the equation of SR. SR is the tangent to the curve. So, oh, no, I didn't read the question properly. The equation of the tangent to the curve at K. Oh, I even underlined K. Goodness. So they're asking for the tangent that will be on the other side, you see. So let's just maybe copy this. And then let us paste it down here. Let us paste it here. So you see, let's maybe put it over there. So what they're talking about is, if you look at SR, right? SR is a tangent to the circle on this side. This is where SR is. Come on, man. Come on, man. We're flowing so nicely. This is what SR is. Right now, this SR, you need to remember that there's a tangent down here, like bam. You see, this is the tangent they're trying to, hey, come on, man. Come on now. Come on, Brody, bro. Why are you not working? This thing is starting to, what? Hey, let's delete it before it becomes weird. Yeah, so this is our tangent, right? With this tangent, they want us to get its equation. So fortunately, what we know is, I mean, like, we just need to use this format. This format is such a hack, you know. It's like you just need a gradient and you just need a coordinate that the line passes through. So the coordinate that the line passes through is x1 and y1. I mean, like, you know, not crazy, not major, x1, y1. And then gradient wise, what is the gradient of everything that we are dealing with? Gradient, what is the gradient? The gradient is our gradient of SR, of which the gradient of SR is just a half. So here we also have a gradient, which is a half, because they are parallel to each other. I mean, like a tangent here and a tangent here, they are going to be parallel by default. You know, it's just how it is, because this is 90, right? And this will also be 90. See, alternating angles. So you don't have to worry too much about that. A coordinate that the line passes through, x value here is a 0, y value is a -3. So here, solving for y, you have y is equal to a half x, and then the 3 comes over, you have a -3. See, because half times x is x, I mean, 2 half times x is a half x, half times 0 is a 0, and then the 3 goes over. And then you have your answer. No, it is good. It's good, this paper. I run a line all the way until now. I feel like this paper has been like so easy. It's like pap and flace, pap and meat. So determine the values of t such that this line cuts the circle at 2 different points. Well, with this kind of a question, like they're just trying to say, if you look at what t is representing the y-intercept of this line. You see, this line here, the y-intercept is a -3, and then this line here, the y-intercept is a 7. So if you compare the two lines up here, right, we know that this is technically a 7 because that's the y-intercept of one of our straight lines. Down here, the y-intercept is a -3. So the big idea here is, if you look at this tangent, right, let's take this tangent here. It's doing that thing again. If you look at this tangent, right, I mean, technically speaking, t is the effect of you moving the graph up and down. I'll say that again. Let me actually just copy this thing here and bring it down, because here we just need the image to explain the answer. It's 3 marks, yes, but we're literally just going to be explaining it, verbally, because there's not much to write anyways. So here, if you look at it nicely, right, this is your tangent. Now the value of t here is a -3. As you move it upwards, let's say until somewhere there, your value of t will be a 0. If you keep moving it upwards, let me make this a bit longer. Come on, man, why does this thing keep doing this? Like, it's so annoying. Hey, it's boring, man. It's boring. I have to start again now. Hey. Oh my goodness. Yeah, I feel like this thing wants me to go mad or get frustrated, and I'm like, I don't have the energy to get frustrated. It's so much energy. So this is -3, right? If you move it upwards, let's say somewhere there, you can see that your y-intercept is like a 0. If you keep moving it upwards, you see your y-intercept somewhere there will be whatever this value is. If you keep moving it upwards, your y-intercept somewhere there's like a 7, which is what the t value is representing. So what they're saying is, right, if you look at what we have, thank goodness. I forced it to do what we want. Oh, wow. Good. So what they're trying to say is, if you read again, determine the values of t such that this line cuts the circle at 2 different points. So the way this line is now, right, having a t value of -3, it's cutting the circle only once. But then if you move it upwards to a t value that is bigger than -3, it's now starting to cut it twice. If you keep moving it upwards, it's still touching the circle twice. Moving it upwards, still touching the circle twice, all the way until the t value is a 7 there. It's only touching it once, you see, because anything between a t value of -3 and a t value of 7, your circle is going to be touched twice, you see. So for this answer, you are literally going to say the following. For this answer, you are going to say the following. Never mind. For this answer, right, you're literally going to have to say your t value needs to be between -3 and 7 without including the -3 and the 7. So you have to say t has to be bigger than -3, or t has to be smaller than 7. You can just write it like this. Some people like to write it in one thing, where you have a t here and then you have 2 things pointing in the same direction. So you'll have to say here t is bigger than -3, or t is smaller than 7. You see, this is another way of writing it out. Other people would want to write it in, I don't know, they call it set builder notation, where they'll say t is an element of -3 all the way until 7. You see, all of these, same thing, just being written in like different ways. You see, you can write it like this, you can write it like this, or you can write it like that. It's all the same, you see. So I don't know if I should put here all the same thing, right? Choose one. Choose which one you like to write. So here it says we need to calculate the area of SMK. SMK, the area. Okay, quite interesting. Quite interesting, I guess. I don't know what is so interesting about the question, but I guess it's interesting, because like, why not? Why not? SMK. SM. Highball. Let's try and make it nice. SM. Ah, come on, bro. Come on, Brody, bro. Hey, never mind. Let me just do this. SM and then K. Like that. There is SMK. So with SMK, getting the grade, the what? Getting the what is this? Oh yeah, getting the area here, we have to be super creative. Like this is gonna blow your mind. So if you look at what we have here, right? Your best bet is if you look nicely, if you look at the line PK, right? Looking at the line PK, what you would want to think to yourself is, I mean, like, this is something you have to keep in mind. Looking at our triangle here, right? Your best bet is to make MK your base. I'll repeat. You need to make MK your base. Once you've made MK your base, you need to make SP your perpendicular height. So let me just try and erase this formula side of things here because we are done here. We don't need this. So here you need to remember that for your I'll show you just now why I'm saying what I'm saying. So this here, you're gonna make this your height. This distance here, you're gonna make this your base. Because if you look at it nicely, right? If you look at it nicely, if this image was like let's say another way, like if this image was, let me even crop it out so that I can show you nicely, because if I don't crop it out, it might not be very easy to convince you as to why we are doing what we're doing right now. So let me say save ISO, and then let me paste this thing here. Now look, you see this shape. If you look at it like this, all right, let me do it some more, tilt it some more, tilt it some more. There we go. If you look at it like this, do you see that here you have a perpendicular height here, right? And then this is the base of your triangle. You see, so that's the reason behind why we are doing what it is that we're doing here. We're going to make what is this? We said here SM the base, right? I mean SP is the height, and then we're gonna make MK the base. MK is the base because we want to use the formula half base times height. So SP we can get that using the distance formula. MK we can get that using the distance formula. So nothing too aggressive there. We don't have to do anything crazy, So let us just do what we have to do. So here, what do we have to do? Let's just make this smaller actually, because it's like, I feel like we've made our point. So distance formula wise, do we have S? Oh, we don't have. We don't. This is frustrating, man. But we have, what do we have? We worked at other stuff here. We got we have the gradient of, we have the equation of SR, so we can easily work out S. So this is the equation of SR. Let us use it to work out S. So let's do this. Type, man. Paste this thing here. How many marks is this question? 5. Oh yeah, so it makes sense. It makes sense. I mean, like it's worth it, I guess. It is worth it. So in this equation, we want to get the coordinate of S, and we see there y is a 0. So we can make y a 0 there. It's just x plus 7, right? And then -7 a half x. And then we have to divide both sides by a half. So it's like a half, and then this is like x, right? So 7 divided by a -7 divided by a half, we have -7 divided by a half, which is giving us -14. So this is like -14, right? And then what? Well, I mean, like at this point in time, what do we need? Wow, yeah, so we have the distance then? No, we don't. So from this, so technically so far this is like -14, coordinate 0. So S and M, we can get that distance using the distance formula. So I think this I don't have to wait, let me actually keep it here just in case, because people may want to know why we did or do what we are did do. So let's do this thing here. So let's get SM using the distance formula. So we can say here -14 minus the -2 there. So let's see, SM, the distance there, we're gonna say -14 minus the -2 there, and then we're gonna have 0 minus 1 squared. This is gonna give us SM, of which we can just use the calculator, because like, why not? Why not? So SM in this case, did I go overboard? Like, am I even working out the right thing here? SMK. Oh no. Why do I need SM? I don't need SM. The perpendicular height is SP. Oh my goodness. Yeah, I would really want to edit all this out, but then I'll leave it so that you can also see that flopping, yeah, it can be very frustrating. Because wait, no, everything is fine. I shouldn't be getting SM. I should be getting SP, because SP is the perpendicular height. Yeah, that's the mistake here, not SM. SP. So SP here, it's going to be -14 minus the 4 there. So it's going to be square root and then -14 minus the 4 there. And then here we have 0 minus the 5. 0 minus the 5. And then let's see, square root symbol, -14 minus 4 squared, and then plus -5 squared. So this is like square root of 349. Yo, does that seem very convincing? I don't lie, it doesn't. I made a mistake here, so I need to fix it. It's a plus, bro. It's a plus. You see, these small mistakes, they like creep up on you when you're like literally almost there, and you're like, it's not happening. It's not happening. So yeah, this looks fine. This is gonna be 5 square root of 5. 5 square root of 5. And as you can see, it's a bit messy, this question. So you would just want to like look out for like simple errors. So here we can now just get MK. MK is not too bad because M is like, yeah, MK, we can get that by saying -2 minus 0, -2 minus 0 over there, and then 1 minus 3. So it's going to be a plus there. And then all this in the calculator. Let's see, we're going to have -2 minus 0. Hi, dude, why do I even have to put all this in the calculator? I don't have to do anything, put it all in the calculator. I can just, wait, I think we have MK. MK is the radius, bruh. Hi, and I'm working it out again, and we don't even need to. We already have it. It's just 2 square root of 5. So, yeah, my brain is just tired. I guess, yeah, more. So here the area, therefore area is just equal to half base times height. Half multiplied by the base multiplied by the perpendicular height, you see. So that this is like a half multiplied by 2 square root of 5 multiplied by 5 square root of 5. There we go. That's going to give you an area of 25. Fantastic, man. Fantastic. Good. Okay, so I guess this question was quite interesting. Yeah, it was one of the really, really interesting ones. This one, it's like, what? Anyways, let us move on to the next question. Here we are not taking any prisoners because hey, don't you have to like feed those people and stuff? That's too much work. But hey, let me not offend anybody. Sine yada 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 yada. For 6 marks, we have to simplify the expression to a single trigonometric ratio. Anyway, so cases like these, like I always say, just try and flip them around. Just try and like flip them around, because if you flip them around, you will be able to still use the cast diagram. So to start off here, I'll just write this like this, and then let's just do it. Why are we wasting time? Let's just do this, So for this, right, we are going to change it to sine negative 360 plus a. And then in your cast diagram, you have to be careful. In your cast diagram, right, CAST, the idea is anytime you work with your cast diagram normally, you always go anti-clockwise, you see. But the moment you're starting with a negative value, you have to go clockwise first. So this is saying negative 360, right? And then you plus an angle, you see. So you end up here, which is in the first quadrant, where everything is a positive. So this is just positive sine A. That's why here you're going to put sine A multiplied by this. Cos 90 plus. 90 plus is going to land you in this quadrant where only sine is a positive. So here you have to be careful to put negative sine A. And keep in mind the brackets, because the brackets remind you that you're multiplying these two. You're not saying this minus this. Normally, if you don't put a bracket, that's where you end up finding yourselves. That's when you end up finding yourself making silly errors. Down here, 90 minus lands you in the first quadrant where everything is a positive, and anytime you're dealing with 90, that's the only time you change from one trig ratio to the other, from sine to a cos or from cos to a sine. And then here you're also multiplying, right? 10 with a negative a. Anything that has a negative angle here will always come out as a negative, except for cos. So here you have to put negative 10a. And then you see the brackets are important, because now we are seeing that this multiplied by that is just sine, but forget the whole sine squared whatever. You see, this can just cancel that, and then this negative can cancel that negative. And then here you technically have sine A. Let's put it over 1 because we are dividing by 10a. Let's put that over 1 also. But then forget the over 1 part. All I'm trying to do here is I'm trying to make sure this is a fraction and this also a fraction, because now, I mean, like, we can just change this to sine over cos. This is sine A over cos A. So that we can change this to a multiplication symbol. This is going to be cos A, sine A. And then here we have like sine A over 1. And then from here, sine times cos is like sine A cos A, the whole thing over sine A, of which we can just cancel the top and the bottom. Cancel this, cancel this. So this is your single trigonometric ratio, cos A, you see. There you go, there you go, there you go, there you go, there you go. Oh, there you go. Blah, 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 blah. Yeah, that is not very necessary. Anyways, so we have our single trigonometric ratio. Nothing crazy with that question. The next question here, I mean, it's our classic normal trigonometry stuff. It says in the diagram, P coordinate T is this point. Might as well draw a right angle triangle already. And then it says here, it is this point in the Cartesian plane. OP is square root of 35, and then HOP is HOP. Where is HOP now? Oh, the whole angle here is beta. So fortunately, whenever you have this whole funny dumb thing happening, just look at this as beta. Trust me, just do it like that. It'll make your life easier. So it says here, without using a calculator, determine the value of T. Well, without using a calculator, we need to get the value of t. Well, I mean, like we can just use, Pythagoras, because this is hypotenuse here. This is, remember, x is 3, so the distance from here to there is 3. So the distance from here to there is a t. So Pythagoras theorem will tell us that square root of 34 squared is equal to t squared plus 3 squared. There we go. And then getting a value of t is going to be 34 here, t squared plus 3 squared. And then here you have like 34 minus 9, because the 3 is going to go over. 34 minus 9 under square root. What you get? What you are get over there is going to be 25. And then if you square root both sides, you are just going to have 5. We didn't use a calculator. Nope, we did not. So they want 10b now. So here we know that this is now, you have to be careful. Here we have to put plus or minus, right? Because I'm like, anything under square root, it's one of two answers. But because it's down here, we have to put a -5. So here, therefore, she's got -5. So yeah, I'll be honest, with these kinds of questions, these are the ones where it's so easy to like forget about the negatives and all that. It's like so easy to forget. So anyways, 10 beta here is just an opposite over adjacent, which is like -5/3. Cos 2 beta. I mean, this is double angles. Anytime you get double angles, always change them into something first. You can actually choose anything. Let's just choose here 2 cos squared beta minus 1. Because, I mean, like, when it's like this, you cannot do anything. At least here, we just need a value for cos beta in our sketch. So cos beta is adjacent of our hypotenuse, which is 3 over square root of 34. So here, 3 over square root of 34 is the part that's squared, and then minus 1. And then all this we can put in our calculator. I mean, like here they said we should determine without using a calculator, but then, I mean, fine. We'll just not use our calculator until whenever. So here 2, right? The square means it goes for the top, which is a 9. For the bottom, it's going to be a 34 only. And then minus 1. So you can just be using a calculator bit by bit. Like 3 squared is 9. Bottom part squared is this. And then obviously here, this is going to be 18 over 34 minus 1. I mean, this, you might as well just use your calculator, because I'm like, come on, bro. Like, hello. Like, come on. Follow the rules, but be smart about it, eh? So here your final answer is just going to be -16 over 34, and then rounded off, or not rounded off, like simplified, it's just going to be -8 over 17. Whew. Yeah, we're cruising. We are cruising like a Land Cruiser. Arch. So anyways, 2 marks here. We need to prove that the left is equal to the right. Yeah, I think here you may have to just use your compound angle formulas, because yeah, it doesn't look like we're going to do something very extravagant here. It doesn't look like we're gonna do anything very extravagant. We're just gonna use the compound angle stuff. So to use the compound angle stuff, you might as well just expand this. So expanding this here is just gonna be sine A, and then cos B, and then plus cos A, and then sine B. That's the whole thing. Here we're subtracting this thing, right? It's gonna be the same thing as we wrote, but with a minus instead. So it's gonna be sine A cos B minus cos A sine B. There we go. Fantastic. Okay, so from all this being done, I mean, like, this is just going to be sine A cos B plus cos A sine B. Multiplying a negative in there, we are going to end up with the following. So is good. This question, I mean, like, if you bump into if you bump into stuff like this in an exam, I mean, they just want to give you free marks, you know. So these are the like terms. This one and this one are like terms. This one and this one are also like terms. So these will cancel each other out, and then you have two of these because it's two of the same thing. 2 cos A sine B. Let's see, sine B, like that. And then you are done. You move on because why not, you know? Of course. Yo, I haven't watched a Majimbo video in like forever, dude. Yo, let's see, without using a calculator. Oh, we're supposed to review. What is the main question? The main question is prove without using a calculator that the left side here is equal to the right. So here we just have to be creative, you know. I mean, like the one thing you're gonna do to prove that the left is equal to the right, just think of how the angles align, you know. Just think of stuff like let's try 90 minus 77. 90 minus 77 is giving us a 13. Let's try 90 minus 43. It's giving us a 47. Let's try 90 minus 17. It's giving us a 73. So we want some kind of a link. Let's try 17 times 2. It's giving us a 34. 34 plus 43, 77. I think we have something there. So I was just playing around with the numbers. So I firstly said 17 times 2 is 34. And then I then said 34 plus 43 gave us a 77. So I think we can do something there, you know. I think we can do something, because what I'm thinking is on the left side here, let's start with sine 77. Sine 77, we can write it as 34 plus 43. And all that was from just playing around with the numbers, you know, doubling them, adding stuff together, blah blah blah. So 34 plus 43 here, and then sine 43 here. Let me just write left hand side. So from here let's expand using our compound angle stuff. So for sine, where you have a plus, let's see, what does it come out as? I just need to check it in the formula sheet. So this is just going to be sine 34. I feel like I shouldn't actually be expanding so much unnecessarily, because but for 4 marks though, for 4 marks, yeah. Hey, let's carry on and see what comes out. Yeah, I'm not very, yeah, it doesn't feel very good like expanding it so much like this without like having any special angles or something like that. It just feels like we're doing it for nothing, you know. But anyways, let's see what this gives us. So this is the left hand side, right? Now on the left hand side, it looks as though for this last part here, it looks like we can take out sine 43 as a common factor. Like like these kinds of questions are, I mean, it's very likely that it might bomb out and then we have to like start again. So what I can safely say is in an exam, I think at this point in time, personally, I would have just been like, hey, let's just move on and come back later. Because moving on and coming back later, it's like a power play, you know. It's like a proper power play where you're like, wait, this is 4 marks. So this should be 4 to 5 minutes, where if I can just not waste it, if I just move on now and not waste the time that I have for this question, you'll be able to just eventually come back to it. But for now, let's see. Even if we take this out as a common factor, I don't think it's going to do anything concrete. Or rather, the way it looks now, it doesn't look like it's going to do anything. But then let's see if the previous question can help us in a way, you know, because these kinds of questions, I mean, like sometimes, yeah, sometimes they're linked. Like here, let's see. I'm already seeing here. Let's try the 17 and the 43. 43 minus 17 is like 26. Yo, okay, that escalated. Let's see, 77 minus 17. That's like a 60. Yo, yeah, ne? But then anytime, I mean, like one or the other, we're gonna need to incorporate special angles in this, you know. So I mean, like from 46 to 60, I mean from 43 to 60, that's like 17. So I feel like the whole 60 thing is really like, yeah. So I think what's easier to do here is, instead of us worrying about random numbers, I think another strategy could be to try and incorporate special angles in here, of which, likely on the left, here we can write sine 60 plus 17. We have another 17 there. And then let's see, for the 43, it's also close to 60. And it's like 17 away. So here we can write this as minus sine. This can be 60 minus 17. Ooh! So you see now, remember we said try and see if the previous question can help you. And then boom. This previous question is definitely looking a lot like what we have here. Because you see the left side here is exactly like what we have on the left here. You see. So automatically we know that the A here is represented by the 60. The 17 is represented by the B. So where we see A here, we're just going to put a 60. Where we see B here, just going to put a 17. And where we see cos, yeah, I think this question is already done. So here, this is equal to 2 cos. It was A is represented by the 60. And then sine is being represented by the 17. That's the left-hand side. So simplifying this, I mean, your best bet is 2 multiplied by cos 60. Cos 60, if you use your special triangles, cos 60, this is like 30 and 60, right? This is like 30 is like opposite over hypotenuse, and then square root of 3. So meaning cos 60 is like adjacent over hypotenuse, which is just a half. You see? So it's a half multiplied by sine 17. So 2 times a half is just a 1. So this is like 1 times sine 17. Therefore, the left-hand side is equal to the right-hand side. Wow. Wow, man. So yeah, man, this is why these videos are there. And you can imagine how things on the course platform are basically just like this galore, where you just have tips flying around, things that you need to follow, blah, blah, blah. So anyways, this is the link to the course website where you shall get, full courses on the entire syllabus from start to finish, going a bit deeper into, these different kinds of topics, of which, in my personal opinion, the best course on the course platform is trigonometry. I don't know. I feel like I just popped off there like way too hard, But anyways, that's that for question number 5. Let's move on to question number 6. Question number 6 here, and we are not playing any games. Question 6 says, in the diagram, the graph this is drawn between negative 270 to 90. And then it says there, yeah, the graph is just cos 2x. So the 2 here means that in a space of 360 you have 2 graphs, meaning it takes 180 degrees to have a full graph. It's just your theory, because your theory tells you that this is the frequency. Now frequency is equal to the period, which is originally 360. No, yeah, 360 divided by the period. That's your formula. Or let me just, why am I busy making, I don't want to confuse the people, but let me just say this nicely. Your formula for frequency and period is this: frequency is equal to what? 360 divided by the period, you see, of which your frequency is always this number here, you see. So the period of our graph, we would be able to get it by using this formula, you see, of which, working at p here, you can just multiply both sides by p. You have 2p equal to 360, divide both sides by 2, p is equal to 180. So that's why in a space of 180 degrees, we are getting a full cos graph there, as we can see. There we go. But anyways, let's see. What is the first question? For 4 marks, they say draw the graph to sine this in this interval on the grid given in your answer book. Show all your intercepts to the axis as well. Well, we might as well draw it here, where we have our cos graph here. So if you're going to draw this graph that they spoke of, you just have to know your properties. of a sine graph or a trig graph in general. So, or rather, let's just make our own image, because like, why not, right? So the best way to understand how to draw this is to understand the standard image. The standard image of a sine graph would have looked something like this, from 0 to 180, and then something like that from 180 to 360. So here until there, this is like negative 180, and then until there, this is like negative 360. Perfect. So nothing crazy there. So with all this being said, right, your standard what you call height here would have been a 1. This would have been like a negative 1, and then your equation here would have been y is equal to sine x. So the issue now is, when this starts to happen, it means that you have a new amplitude, which is a 2, and your graph here has been moved 1 unit downwards. So this is what happens to this image here, right? The whole image here would, if you're going to incorporate the negative 1 here, it means that the graph is moved 1 unit downwards. After moving it 1 unit downwards, your new amplitude is going to be a 2. So your graph will go from negative 1 here all the way to 1, and then come back down, and then like that. But then let's just put that all into practice. So your new graph, right, after these two things have happened, this is how it's gonna affect your image. You have let me just check if this thing is recording, because I'm like paranoia. Let's see. So from what you have here, you have what do you have? You have a Cartesian plane. The first thing we said is that instead of it passing here at 0, right, it would be passing at like negative 1. And then instead of it like having an amplitude of just 1 unit, your graph would start off by going 2 units upwards. You see, so it would go up to like positive 1 here, and then come back down. You see, and then after coming back down here, it would now do 2 downwards, and then go back like that. You see, so you have to remember that you have a new point of reference here for your graph. You see, this is like a new point of reference, meaning that your image would be going down, and then it would come back up here, and all that, of which you have to remember that the distance between the resting point and the highest point, this is just 2, and this distance here is also just 2. You see, but then they would have wanted us to just draw this graph from negative 270 to 90. So from negative 270 to 90, you need to be careful, you see, because you have to remember that the graph was not moved left or right or anything like that. So judging from the original image, let me just erase this here, erase this here, erase this, erase this, erase this, erase this, erase this. So judging from the original image, our original image automatically tells us that here, this is where 90 is, right? Here, this is where negative 90 is. And then here, this is where negative 180. Here, this is where negative 270 is. So they want us to do from 90 to negative 270. So originally, this is what we would have been drawing, you see. But then this image here, it has now been moved 1 unit downwards, and it has what has happened now? It now has an amplitude of 2. So technically we still know that this is where 90 would be, and then according to our image here, somewhere there is where the negative 270 would have been. So here we know that this would only go to like negative 270 somewhere here. I mean, this would be like negative 180, you see. But then what we know is it has to go back up somewhere there. So it would go back up, and then somewhere there, this is where negative 270 would be. So if you're looking at it nicely, right, we already know that, I mean, like, they don't want us to show this whole part here. That's not necessary. So this part we can just remove. This part we can just remove. And then so far we are just seeing from here and then going all the way to the other side over there, you see. So this is what you would draw. And you being able to comfortably draw something like this, it's all based on your theory. Your theory will like help you to see that, okay, wait, I have a standard image, it was moved 1 unit downwards, but then apart from it being moved 1 unit downwards, like the amplitude was changed to 2. So you can just use some way to like help you draw your image, you see, because we just want to focus from here all the way until there. So the image, if you move it 1 downwards, you would have your your y-intercept here. And then if this is your y-intercept, right, obviously if your amplitude is like 2, it means it's going to go 2 down and then 2 up. You see, so here 2 down and then 2 up, like that. But anyways, so far so good. 6.1 is there. Let us move on to 6.2. 6.2 for 4 more marks also. They said let A be a point of intersection of the graphs of f and g. Show that the x-coordinate A satisfies this equation. Well, without overthinking it, this question is just asking you to equate these two equations and end up with this somewhere along the lines, of which that's like not crazy at all. That's not something we need to crack our brains over. Because firstly, we just have to think, okay, fine, f of x is just cos 2x. G of x is just, what is g of x? G of x is 2 sine x minus 1. 2 sine x minus 1. And then, what now? Now we need to equate these two graphs together. So we need to make them equal. So f of x equal to g of x. We're going to have cos 2x equal to 2 sine x minus 1. So the big idea is that you literally need to, what do you need to do? You need to, it is almost like just solving for x or general solution stuff and all that. So let's just be careful here. So here we need to have one trig ratio. It's easier to have a cos here. So let's say, I mean, it's easier to have a sine. So let's change this to like 1. Ah, come on, bro. Come on now. Come on, Brody, bro. Let's see. Brody, bro. Yeah. 1 minus 2 sine squared x equal to 2 sine x minus 1. Everything on one side, you will have here 0 equal to 2 sine squared x plus 2 sine x, and then negative 1 minus 1, that would be a 0. Yeah, so everything on one side, the 1, no, it would come to the other side. It would be negative 2, bro, because it's like negative 1 minus the 1. So here it looks like we need to factorize. And when we factorize here, you have to be careful, you know, because you have to almost look at the sine x as though it's like x, because you see here there's like a 2 something squared plus a 2 something not squared and then minus 2. So it's a quadratic equation. If you want, might as well take out a 2 as a common factor if you want, but you don't have to. I mean, I wouldn't, because what's the point? There's no need. Sine x here is equal to minus b plus minus b squared minus 4ac. And then this is like 2 times a. A is like a 2. So with all this being said, right, let's put all this in our calculator. Let's see, fraction button. Then we have like negative 2 plus square root of 2 squared is like minus 4 times 2 is like negative 2. The bottom part is like 2 times 2. Yep. And we have it. We have it, Baba. Sine x is equal to minus 1 plus square root of 5 over 2. And that's it. Easy marks, easy marks. You get them and you run, man. You get them and you run, So for 4 marks here, let's see. It says, hence, calculate the coordinates of the points of intersection of F and G for the intervals this to this. So this is more like, you would need to just carry on from here now, and do like some general solution shandies. So carrying on from here, right, what you would need to do is you obviously need to get like a reference angle. So let me just rule off this answer here. You see, let me rule off this answer here, and then 6.3, let's start from here. So carrying on from where we have there, you'd need to get a reference angle, for future reference angle. Remember, this number, you have to be careful. You have to double check if this number is a positive or a negative number. So you can just check in your calculator. It's a positive number, so it's fine. So here, shift sign, highball. Come on, bro. Loading. Oh, snap. Okay, fine. So shift sign this over 2, and then what you got there, shift sign this number, right? Shift sign that number. This answer, your reference angle is like 38.17. 38.17. That's the reference angle, of which, because you now have a reference angle, you can now work out where is sine a positive is the first quadrant and the second one. So the first quadrant, you're just going to have there, you're just going to be carrying on with your reference angle. X is equal to 38.17 plus K 360. K is the element of integers. So what I recommend you do so far, because you have been given a domain to work with, as long as you've been given a domain to work with, right, you always need to make use of that value of K to see if you can get other answers within this interval, you see. And this is other things like within the course, like the trigonometry course, where we work on when to use K, when to not use it. So here, this is where you're going to make use of K, meaning wherever K is, you're going to throw in there an integer. You want to think of like 1, 2, 3, -1, -2, or something like that, where if you throw that value here, it will give you an answer, and you have to check if that answer is within the interval that you're working with. So here, let's try -1. So if K is a -1, you can just say here, let, you don't even have to say it. You can just, okay, you can let K equal to -1. So you'll have here X is equal to 38, but it's not going to work out. We don't even have to bother ourselves, because -1 means that you'd have this number minus -360. It's going to be out of bound from here. So from here, we don't have to put the K360 part, because it's really not giving us any other answers. For which other quadrant we need to use? We need to use quadrant number 2. So quadrant number 2, we would have the X is equal to 180 minus the reference angle. So let's see, 180 minus the reference angle, 180 minus the reference angle, that's like 141.83. So yeah, come on, man, come on. 141.83 degrees. So if you think of it nicely, I mean, like, let's see this, if you had to like have the K360 part, I don't think you would end up with any other answers. So let's just move on to, wait, should we, no, let's test it out. Let's see, plus K360. K is an element of integers. Well, if K was like a -1, yeah, I think for this one, this would be your one answer, this would be your other answer. But then it looks like here we can make K like a -1. Let's say I'm forgetting I have space down here. So let's carry on from down here, right? So carrying on here, we can say let K equal to -1. So if K is gonna be a -1, we'll have x is equal to 141.83 minus 360. And then let's see what that gives us. Minus 360. Yep, it's within the range. It's within the given domain. So this is our other answer. Yeah, that's how these kinds of things work. And if we had made, I think these are going to be our three answers. You know, I feel like we could check and check and check, but I don't think we're gonna get any other answers compared to the ones that we are getting now. But we can just look some more. You know, we can just look some more. But then they said, what? Hence calculate the coordinates here. Okay, so here they actually want the coordinates. So we have gotten x values. Now we need to find the y values. We've gotten x values, right? Now we need to find the y values. So yeah, we excuse me. Yeah, so we just have to be careful. And when I say we just have to be careful, well, firstly, okay, this one I should actually rule it out because it's out of our given domain. You see, it's away from the 90 because it's like somewhere there. So these are actually our only two solutions here, this and this. So we have, so the y values for that, we can just get it using our equations. In our normal equations, remember we have the equation of f, so we can just use that to get the y value of these x values. So in our equation of y is equal to cos 2x, right? So y is equal to cos 2 times 38.17. Let's see what this gives us in the calculator. Cos 2 times 38.17, right? And then this is gonna be like 0.24. So that's that. For the other one, we have to do the same thing. Cos 2 times the angle. Let's see what it's gonna give us. Cos and then 2 times the angle, negative 218.17. This is gonna give you the same answer. Y is equal to 0.24. So therefore your coordinates, you are going to do this. So your coordinates is therefore the 38.17 and the 0.24. You're also going to have negative 218.17 and then the 0.24. There you go. These are your coordinates. Wow, this was quite an interesting question. But then, like I said, I mean, I'll keep repeating this until it kind of sinks in. If you need more practice on these kinds of questions, right, for you to get more and more comfortable with them, then you really do need to sign up for the online courses on our website. You see, the link to that is in the description, because we obviously do deal with these kinds of questions extensively. But anyways, we're going to move on to question number 7 now. Question number 7. Okay, so we have an interesting 3D image here. Yeah. It says AB represents a vertical netball pole. So there's AB, yeah, representing a vertical netball pole. And then it says 2 players are positioned on either side. So 2 players are positioned on either side of the netball pole. Okay, which is at points D and E. Okay. Very interesting. D and E over there. You have a player there. You have a player there. At points D and E such that D, B, and E are in the same straight line. The third player is positioned at C, which is like somewhere here. And then it says that the points B, C, D, B, C, and D and E all line in the same horizontal plane, like they are all on the ground. You see, that's what they mean. And then they say here the angles of elevation from C to A is, this is like X, and then from E to A, this is like Y. Interesting. Okay, so if I don't think this question is going to be too bad. It says the distance from B to E is K. So the distance from B to E is going to be K units. Interessant, man, interessant. Okay, it is what it is. So all this being given, for 1 mark they say draw down the size, write down the size of ABC. The size of ABC. Okay, so getting the size of ABC, you have to be careful with all the questions that you will always be asked, right? When it comes to like a 3D shape, you always have to focus specifically on a specific triangle for that specific question. So the specific triangle here would be A, B, and C. So they want this angle here. I was about to make the mistake of making it a 90-degree angle, but it's not a mistake. Look at this mark allocation. I'm pretty sure it's like 1. Yeah, this angle is 90 because this is like the angle between the ground and the pole. I mean, like a pole is always going to meet the ground at an angle of 90 degrees. That's just logic. So this angle here is just 90. So this here is just 90 degrees based on pure theory. So this is 90. This is also going to be 90. And that one is also going to be 90, you see. So we need to keep that in mind for when we will work with these individual triangles here. So the next thing for 4 marks is they want us to show that AC is equal to this. So anytime they want you to show something, don't focus on the showing. Just focus more on the triangle that is dealing with those dimensions. What I mean is, if you look at it nicely, I mean, like, we are being asked to get AC. So AC is this line from the top going down here. So it's in this triangle that we have just drawn. So thinking of this triangle that we have just drawn, let's give it dimensions. You see, so the dimensions we don't have this, we don't have that, we have nothing, we only have X there. So looking at our image, I'm like, we only have X. It's so plain. So what you need to do is you need to use the rest of your sketch to get more information into this image. So the other triangles that you have is the one on the left here, which looks like this. This one practically has nothing because it's just like A, B, and there's D there. This one has nothing to contribute. The one on the right, though, has something to contribute because the one on the right has K, the one on the right has Y, and it has a 90-degree angle. And the fortunate thing is the link between this triangle here and the other triangle there that has the K is this line. They both have AB. So that's just like the rule of thumb. The line that joins two triangles is the line that you use to get more information from one triangle to the other. Because this line AB here in this triangle ABC, if we can just get AB using this image, we'll have more information in here to get AC. So for questions like these, the question being asked is not what you focus on first. What you focus on is getting information into the triangle that is going to help you answer the question that is being asked. So that's why here we may want to focus on this triangle first. Let's focus on this triangle and get AB, of which you getting AB, all you need is an expression for AB. You don't necessarily need like the actual thing with numbers and everything. No, you just need an expression for AB, meaning here you can see this is going to be adjacent. Let's see, opposite over adjacent. You see, that's what you can do here. Opposite over adjacent. So 10y, actually 10y is just opposite, which is AB, over adjacent, which is like K. And then here you can isolate AB by multiplying by K on both sides. You see, there you go. Let me not make this 10 a capital letter because it's just weird. So now we have something for AB. You see, so because you now have something for AB, it's making your life much easier now, because look, in this shape, right, where there is the AC we're looking for, in this shape here, There's A here, there's C here, there's B here. Here we know this is K10Y. We already know that this is just X. And then we know that they want us to get this line. So if you noticed, whatever we were doing, we never even focused on the big picture. We only focused on it in the beginning. And then whatever we had to work out, it was just working it out individually one by one, you see. So carrying on here, we can also just think of normal trigonometry. Let's see, this is like opposite, and we're looking for a hypotenuse. So it's just going to be sine x. Sine x is opposite, and then over hypotenuse, which is AC. So because AC is at the bottom there, you may want to make this a fraction so that you can just cross multiply. This is going to be AC sine x, and then this is going to be K10y. And then obviously you can just divide both sides by sine x. So this is just going to be AC is equal to K10y over sine x. And then that's exactly what they want you to have. You see, you almost like bump into the answer just by flowing, you know? And the one way to flow is, I mean, don't overthink it. You see, when you're dealing with 3D triangles, don't overthink it. Always think in terms of, you know, the different planes here. This is in the horizontal plane. This one is in the vertical plane. So this is going upwards, and then this is like on the ground, you see, on the ground, on the ground, on the ground, on the ground. So that's the idea behind this 3D triangle question before we move on to this one. So for 5 marks though, they said it is further given that DAC, where is DAC? DAC, oh, now we're working with this triangle. They say DAC, which is this angle here, they said it is equal to 2x. So let's actually just get this down here. They say this is equal to 2x, right? This angle here is equal to 2x. Okay, fine. Hey, 2x. And then they told us that AD is equal to AC. So whatever we got for AC, we can write it here also, because that's what they told us. For AC, we got this. So they said they're equal. So whatever we got for AC, we're going to put it for AD. And then they say they're sure that the distance DC, where is DC now? DC is from D going to C down there. So this is like a new line. The distance from DC, they say that sure that the distance DC between the players D and C is this. So what this has done is it has just introduced another triangle in our image, of which this triangle is like in the horizontal plane. It's on the floor, you see. So you getting information, or you getting information of this triangle, you don't need to overthink it, you see. So let me actually just do this so that I can just cut it out and work on it at the bottom. So this triangle, this new triangle that we are working with, right? You need to keep in mind that this triangle here has, let's give it the dimension, it is DBC, right? So let's see, there is DBC. This triangle is empty. It's like plain. There's nothing in there. So obviously, if you're going to get the distance DC, you need some information in this triangle. And it's not a coincidence that this is 5 marks. The reason it's 5 marks is because you're probably going to need to get so many things here. You're going to need to get this line, an expression for that rather. You can get it from this triangle, of which you might as well just do it. Getting this, remember this is a 90-degree angle. So getting this is like adjacent over hypotenuse. So it's like cos 2x, which is adjacent. No. Yeah, adjacent, yeah, over hypotenuse. Your num. Yeah, you might want to put this over 1 so that you can write this as something next to it. So it's dB divided by this. The reason for writing it like this is because this is easier to work with, you know, because here you can just tip and multiply. You can just flip it over and then just multiply. So it's going to be sine x at the top, K10y at the bottom. cos 2x, like that. And then what now? We need dB. Oh yeah, we need to isolate dB. So isolating dB, this is gonna look weird, né? But trust me, here we might as well divide the whole thing by this. So here you're gonna have dB on its own, right? It is equal to this divided by that. So it's gonna be cos 2x divided by this. Yo, I should have just yeah, man. Yo, it's crazy, man. It's crazy. Mathematics is crazy. Like, yo. So it's just algebra here, we're just executing algebra. So from here, cos 2x, we're going to flip this over and multiply. So you're going to have k 10y, the whole thing over sine x. That's dB. So this is a bit too chunky. So we might as well just maybe try and break it down some more. But then to be honest, I don't think breaking this down some more is going to lead anywhere. Because judging from where we're ending up, yeah, we might as well leave it like this for now. So far, we have dB, which is interesting. So do we have BC? Do we have BC somewhere somehow? Well, we can get BC, but then it's like, hey, it's gonna be so messy, bruh. It's gonna be like so messy, Oh, excuse me. Yeah, it is gonna be so messy because BC, we can get BC by saying 10, right, which is opposite over adjacent, because AB we have. AB is what? AB, we got it to be K10y. So if you're looking at this triangle where we need BC, there's B down here, and then there's C down here, then there's A. A we have, right? It is just K10y. K10y. And then this angle here, they gave it to us as X. So this is going to be an X over here. So to get BC, we have to say opposite over adjacent of algebra. So we're going to have here 10x. 10x is equal to opposite. There's opposite here over opposite over adjacent, right? So that's BC. And then from there, isolating BC, you can just cross multiply first. You're going to have BC here, and then 10x, your life. So that and that, K 10y. Divide both sides by the 10y, you're going to have BC equal to K 10y, and that's BC. So as you can see here, we now have BC and dB. It's flowing. Okay, it's not that flowing, but it's something. So we have BC and we have dB. So the question now would be, but then how is that eventually helping us to get DC? And yeah, to be honest, it's like, it feels like we're just like doing things in such a mess. And it does feel like such a mess. And the other thing is, I'm also thinking to myself, but wait, why did we even have to do that when we could have just used another triangle? Oh yeah. I think this is one part of the paper again where we've done so much and it's just like, no man, this is not going to work out. So I'm not even going to edit it all any of it out, because I'm just going to show you none of this is, it doesn't look like this is working out, because it just seems a bit too far-fetched. So what's easier to do is to already use most of what's there. When I say use most of what's there, I mean, if you look at what they told us that AD is equal to AC. The one thing I missed is that if you look at our main image, this is equal to that. So we might as well just we're going to draw a line here, yes, but then our triangle would be the triangle, this one. Let me just draw it. This is the triangle we would use to work out what we need to work out, because this is already an isosceles triangle, so it makes our life easier. if you're dealing with this, if you're dealing with that, and then if you're dealing with that, you see, there you go. So the big idea here is that if you use triangle ADC, you're in a much better space. So let's just actually use ADC and not all this other nonsense, because hey, it was not working. So I think also it goes back to in an exam, if you had done something like that and it's like not working, say you did see the light, you might as well carry on with the question. But if you see that it was bombing out, then you might as well carry on, and then later when you come back, you would have probably spotted this. So they told us that these are equal to each other, and we worked out AC to be K 10y blah blah blah, K 10y over sine x. So this is also K 10y over sine x. Yeah, so this is an isosceles triangle, meaning that the angle on the left here is equal to the angle on the right there. Okay, now let's see if that's going to help us a bit more. Well, I hope it does. Let's see what else they told us here. They told us that, oh, now it makes sense why they told us that DAC is 2x. What did I do with why did I put 2x wherever I put 2x? Wow, DAC. Yo. Yeah, I had flopped so hard. Whew. Yeah. I'm pretty sure most of the recording, you were like asking yourself, what is it doing? Like, what is it doing? So I think I'm gonna leave it in there, because at least you're gonna also see that, you know what, ne? Sometimes some of these things, it's so easy to make dumb, silly mistakes. Because here now we can just use the cosine rule, you know? So using the cosine rule, I think I probably should just edit it out. So using the cosine rule here, we are going to, the reason we're going to use the cosine rule is because we have two sides given and we're looking for a third one. And we have an angle in between the two sides. So according to the cosine rule, the side you're looking for is going to be on its own. DC squared is equal to AD squared plus AC squared minus 2AD AC multiplied by cos the angle, which is angle A. And then DC squared here. AD is like this, right? K 10y sine x, the whole thing squared. K 10y sine x, the whole thing squared. 2 K 10y, and then here sine x. Also here K 10y sine x. Whew, yeah, I need to shrink it because I did feed it too much. Need to go to Virgin Active. Oopsie. I did not mean to offend any port. But anyways, this is cos, and then angle here is just 2a, 2x. Okay, yeah, so here it's just a matter of working with like terms, really. Because if you look nicely, this plus this and this, these are like terms. But then this also, okay, let's just do it bit by bit, you know? There's no need to rush. This and this is going to give you 2k 10y over sine x squared. And then this multiplied by itself is going to give you k 10y sine x squared. Now, don't make the mistake of canceling these two. They're not like terms because of the cos x there. What you can do, though, is to take it out as a common factor. You know, if you take it out as a common factor, but then, let's see even, what is DC supposed to be? They say DC, we should prove that it is what? Prove that DC is 2k10y. We have to be creative here. So in terms of us being creative, yeah, what can we do? Hi, Bowman. I feel like this whole k10y sine x thing But then because there's a tan y and a sine x, it really cannot be like, it can't be made as simple as we think it can. But let's what, take it out as a common factor, and then what? Because I'm thinking to myself, yeah, we can take it out as a common factor, and then what after that? That's where like the blonde moment is coming from. Oh yeah, that's why this question is like getting frustrating, because it's like, unless I took the wrong thing also. AC is, what did they say is equal to each other? AC is equal to DC. AC is equal to AD. And this is what AC is. Yo. Yeah, maybe I'm having a blonde moment. So let me just maybe see what I can come up with, because it's like, it just doesn't want to work. Like, it just doesn't want to work. And it's like so irritating. Because it's like because I'm thinking to myself, how do we end up with this? Like, what? Hi, Bowman. Sure that the distance DC is that, yeah? Unless even the cosine rule is like a bit too far-fetched, Because I'm looking at it now and I'm like, what? Hi, Bowman. Nah, fam. This is not on, This is like not on at all. But the show must go on, The show must go on. So I'm literally looking at it some more and I'm like, hey, when are we going to like, Oh yeah, you know what? I feel like this is the kind of a question that needs us to just have krach, We just need to be strong and we need to not be scared. So let's just take it out as a common factor. 2k 10 y over sine x. If you take it out, you're going to have 1 minus cos 2x. So now that we've taken it out as a common factor, yeah, I'm definitely thinking to myself, now what? Like, now what? So, okay, I think here, because there's a sine x down here, we may want to change what's inside there to something that has a sine, so that maybe some canceling out can happen. So here, dc squared, it's going to have this thing here, k tan y over sine x squared, right? And then here, 1 minus 2 sine squared x. And then here you're going to have 2k dot 10 y over sine x. So here, if you multiply inside, right, you're going to have 1 minus 1. So the 1's cancel out. And the negative times the negative 2 is going to give you a positive 2. So this is actually going to be positive 2 sine squared x over 1. I think things are looking up finally. Because now look, the whole top here can multiply by each other. The whole bottom can multiply by each other, you see. So you're going to end up with like dc squared here is equal to 2k. Oh, no, the squared. Oh, no, the squared. Ah, bugger, man. Yeah, the squared there is just making life not very entertaining right now. Like, it's not making life very entertaining. But then I feel like we have we can, if we're strategic, right, this and that is going to give us like a 4. And then we have 4 sine squared x. And then here we have k tan y over sine x, the whole thing squared. This is over 1. So luckily both the left and the right, they are square numbers. So we can just square root the left, square root the right, so that we end up with dc. Oh, why did I not give myself enough space for this question? Wasted space up here, like what? This sucks. But anyways, so from here you're gonna have dc, right, equal to 2 and then sine x and then this thing here. You see, because the square root of 4 is a 2, square root of sine squared is sine squared, square root of this whole bracket is just that whole bracket, you see. And then what's going to happen is the sine x here is going to cancel the sine x over there. And then you have dc equal to 2k 10y. So yeah, this is definitely level 5 kind of question, and it's not very pretty. So you can already see that, I mean, like when we're talking about moving on and not having to have been done with the paper, blah blah blah, I think that is a good enough hint to say that for these kinds of questions, do not waste your time. Move on. You can always come back to them if you really want to. Yeah, so let's move on to question 8 now. Question number 8. So with something like question number 8, right, we have to be like what? It's Euclidean geometry. So this is where things get entertaining. And I don't lie. I kind of like Euclidean geometry these days, you know, like we're vibing, you know, we are vibing. So it says here in the diagram, points A, B, C, and D lie on the circle. Points A, B, C, and D. So that would have been a cyclic quad if those 4 points were joined. Oh wait, oh okay, if you had a line here and a line there, you'd have a cyclic quad. But then anyways, already because of those 4 points, if this is 50, this is going to be 50 because angles in the same segment. And then it says here ECE is parallel to AB, so that's very important because the moment we see parallel lines, we should already be thinking of fun. You know, because why not? But then apart from fun, I mean, like as long as we're dealing with Euclidean geometry, we have to think of Dr. Cape Town. You know, if you're not familiar with Dr. Cape Town, just go to the main channel, Bright Young Brains, and then search for strategies to approach Euclidean geometry riders. And then you shall find out that this is going to remind you of diameters, radiuses, cyclic quads, parallel lines, and tangents to help you answer questions easier. So here, they told us that CE is parallel to AB with E on AD. E is on AD. Where is E? Where is E? E here on AD, going all the way to E, produced. And then it says chords CD and AD. Where is CD? CD and AD intersect at F. These intersect at F. And then it says here D2 is here. That's a 50. D2 is a 50, right? And we said it is equal to the B over there because the angles in the same segment. And then it says C1 is equal to 15. C1 is equal to 15. There you go. So with all this being said, right, for 3 marks, we need, or whatever we're going to do, right, we just need to do our best, obviously. So angles A. So let's see here. Let's see. Angle A, they're asking us to get the angle A for 3 marks. Well, I don't think that one is going to be difficult because normally if you have like actual angles given, yeah, that's when you must shine, eh? That's when you must really like hammer the questions. So let's see. We have alternating angles. We have this whole thing here is 50. Here this whole thing here is 50 because it is equal to angle B because they're alternating angles. You see this, that. So we have to say C is equal to B, alternating angles. So the reason for that is we want to get this angle. If we can get this angle, we know that it is equal to A. You know, because normally if you're going to find an angle, find something that it is equal to, and then use that as a guinea pig. You know, so here we're going to get C2 over there. But firstly, so C2, we know that here we can say therefore C2 is equal to 50 minus 15, which is 35. Yeah, that's more of a conclusion from the green statement over there. Because I mean, like, the whole thing is 50. So 15 is that's something that they gave us. So now that we know that this is 35, now we can say that therefore the A is equal to the C2 there. So here A is equal to the C2, which is equal to 35. The reason is angles in the same segment. There you go. Angles in the same segment. So those are angles in the same segment. And we shall move on now. Where are we moving on to? Well, we're moving on to wherever we're moving on to, you know, because, like, why not? So C2 now, we need to get C2 for 2 marks. So let's see here. C2 for 2 marks. Wait, C2. What? Really? I feel like we went. Yo, I feel like did we like play ourselves or what? Because it's like, what? We got C2 already. Like, you see now, maybe there was like another easier way of getting A. You know, who knows? Maybe there was, but like, us, we already like answered the question, you know, and we have moved on, so we're not going to be crying about, you know. Yeah. Oh yeah, but we didn't tell them that this is equal to 50. Snap. Oh well, might as well. Oopsie. B is equal to 50, or rather B is equal to what? D2, right? Which is equal to 50. And the reason there is angles in the same segment. Yeah. So yeah. Moving on. Yeah, I think for here you can just, you don't have to worry about it, you know. C here is equal to what's the answer? 35 degrees. Because we proved it here, we can just literally say proven and then give the question number 8.1.1, because we proved it in the previous question for us specifically, you know. And it's just a 2-mark question, so you don't have to do any funny business there. Prove with a reason that CF is a tangent to the circle passing through point CDE. CF, where's CF? We need to prove that. Hey, let's just take a screenshot of this then, so that we don't have to keep scrolling up and down. We don't want to keep doing that. Oh, oopsie. I guess it's too late. Let's see, past there. Let's crop it out, my guy. Crop it out. Whoa. Crop. Okay, no, not cropping it out. So with all this being done, what did they say? They said we should prove with a reason that CF. Where is CF now? Huh? Yeah, there is CF. CF is a tangent to the circle passing through points C, D, E. So a circle would be passing through those points, right? So it would be like a weird looking circle, that one. Yeah, it would definitely be a weird looking circle. So this circle would be like, let's make it bigger, bro. Let's make it an actual circle, you know. Let's draw it. Make the circle bigger. Blah, 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 blah. Yeah, this circle is gonna be more of an oval, but it'll help you see the picture, you know. So let me. Come on, it was looking so well. I feel like this should be fine. So they're saying that a circle, we have to prove giving reasons that CF. So CF is this tangent here. If you see, CF is this tangent over here. You know, I feel like I can give this a different color, like, definitely. Let me give it like a red, you know, like, so that it can like pop like champagne. Champopo. Yo, what is that, bro? What just happened? What just happened? What are you talking about? Yo, nah, it's this thing, man. Come on. Yeah, they're saying we should prove that this line would be a tangent to this orange circle. Now the easiest way to show that that line is a tangent to the orange circle is to show the 10 chord theorem. It's literally like standard procedure, you know, with a question like this. Always think of the 10 chord theorem and literally just prove it based on the question. So all you want to do now is to maybe show that if this is 35, then this angle is also going to be what you may call 35. You see, because of the 10 chord theorem. Because for the 10 chord theorem, this has to be 35. This is 35, but then it means that E also has to be 35. So if you can just show that E is a 35, you're good to go. And it's so easy to do for this question because look, you have triangle C, E, and like D, right? Like this. Of which here we can already see like an exterior angle. This is 50, this is 15. So here already you can say that this is 35 using what you call exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of the opposite interior ones. So already here you know that D2 is equal to C1 plus E. The reason is exterior angle of a triangle. So here you can say therefore D2 is equal to no, here you can say therefore the numbers. You can use the numbers now. Therefore 50 is equal to 15 plus E, right? And then if this goes to the left, you're gonna have 50 minus 15, which is like 35. And then if this is like 35, what now? Well, if that's 35, then I mean you're done. Now you can say the E is equal to the C2, right? So you can say therefore C2 is equal to E. You know, you've just proven it. So because you have proven that C2 is equal to E, you can then now say therefore CF is a tangent to the circle passing through that. CF is a tangent to the circle passing through what? CDE, circle passing through CDE because of the 10 chord theorem. You have basically shown that your sketch is representing the 10 chord theorem, because if there was a circle here, then this would need to be equal to that, and you have shown that yes, this angle here is equal to that one. So that's for 2 marks. That's why this is just a 2-mark question, because it's also like a very common question that they ask. So yeah, we're gonna move on to question number 9 now. Question number 9. Oh, Yona. I don't regret what I said though. I said me and Euclidean, we are vibing these days, you know. So let's just try and live up to that claim. It says in the diagram A, B, C, D, and A, C, D are drawn. Yeah, I don't align. These kinds of questions, they just make me think, Huri, you know what, with math, like, is this really necessary? Like honestly speaking, like, is this going to help us pay our taxes and all that? Like, but you know, I always say like school is literally just there to build resilience, because some of these things that have to be done, it's like just to build resilience. Let's not lie to each other. But anyway, so we have those 2 triangles. They are drawn. It's the small one on the left here and like the slightly bigger one on the right over there. But let's leave out the coloring and all that, because that's not necessary for now. And then they said they are drawn. F and G are points on sides AB and AC. So you have F and G, right? So where is F and G? There is F and G. And then they said here they're drawn on those 2 sides respectively, such that this is 3x, this is 2x, this is 12y, this is 8y. You see, this is to show that these are ratios, not dimensions. And then it says here GC minus 8y. I think they meant equal to. Oh yeah, yeah, equal to. They just looked like very faint. That's 8y. Yes, we can see it over there. And then it says here H, E, and K are points on side AD. Where's AD? AD such that GH is parallel to CK. Yes, and then GE is parallel to CD. Okay. Well, I think for the parallel lines, these ones we could color code them because, yeah, why not? So the blue ones are parallel to each other because, why the not? They said, why the not? So these are parallel. And then for the pink ones, also parallel. There we go. Let it go. Let it go. Blah, 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 blah. Okay. Whew. Yeah, this question is going to be quite interesting. They said prove that FG is parallel to BC. Well, I think this one is not going to be too crazy because you just have to prove the proportionality theorem here. So here, AF over FB, this is equal to like 3x over 2x, which is just 3 over 2. And then here, AG over GC, this is equal to 12y over 8y, which is equal to 12 over 8, which is 4 can go into both of them. 4 goes in here 3 times, 4 goes in there twice, you see. So here now we can say, therefore, AF over FB is equal to AG over GC, So then here we can then say, therefore, FG is parallel to BC. The reason is proportionality theorem. You see, the proportionality theorem shows us that those two are parallel. So these are, I would say these are just free marks, like, to be honest, like, thank goodness, free marks. So after having to have gotten those free marks, we now have to prove something else. Prove that AH over HK. So where is AH? AH over HK is equal to AE over ED. Where is AE over ED now? AE over ED. AE over ED. So with these kinds of questions, right, I mean, like, the least you can do is to have as much information as you can on the other side of your image. Because if you don't have enough information on this side of your image, right, then you're just wasting your time, So let's just erase all this for now and get as much information as we can on this side. So to do that, this is the tactic. So firstly, you already know that 12y is here and 8y is here. So you already know that. Let me see. Oh, there's so much space. Yes, might as well like get this image down there because it's like I can't keep scrolling up here. We don't want to keep scrolling upwards. We want to be writing, seeing the image. So this question, I really do believe it's about to like help you understand the proportionality theorem and how these kinds of questions work. I believe this question is about to open your mind. Mark my words. And I like to make promises that I can deliver on. So because I have made that promise, the boy is ready to deliver, guys. The boy is ready to deliver. But the other thing now is this is just like a 3-mark question. So I hope I don't like, like just go overboard, because that would be bad. So the idea is you just want to take things slow, get as much information on this side of the image. So what we know so far is if this is AG over GC, it's 12y and 8y. We know that AG over GC is equal to AH over HK because of the proportionality theorem. So let's just keep that in mind. Let's write it out. AG over AC is equal to AH over HK. The reason is this is 12y over 8y. The reason is just proportionality theorem, of which this is just going to be equal to the 4 over 3, like we said. No, 4 over 2. No, 3 over 2, bro. 3 over 2. So this is HK, you see. So we now know what AH over HK is equal to. So here we can say, therefore, AE. No. What am I saying? I'm trying to say that on the right-hand side here, we can write this as 12y, and we can write this as 8y. Okay. So what we also know is that what else do we know? Oh, it's hard. It's very, very hard. Wait, what we also know is that if you are dealing with the pink lines, if you're dealing with the pink lines now, if you're looking at the pink lines, you also know that AH over GC is equal to AE over ED because of the proportionality theorem. You see, this over this is equal to this over that because of the proportionality theorem, if you're looking at the pink lines. So from here, we can then say 12y over 8y, AE over ED. And then from here, 3 over 2, AE over ED. Therefore, AH over HK is equal to AE over ED because we have shown that they're equal to the same thing. Whew, fantastic, right? Yes, definitely. So with all that being said, for how many marks here? For 5. Oh my goodness. Whew. Like I shouldn't have reacted like that because it's like 5 marks. Like, yo, bro, afraid of 5 marks. Well, you should be happy. You should be happy that you're about to get 5 marks all at once. That's what I always say. But anyways, it says here, it is further given. Let's actually just put the sketch here because like, why not, right? It is further given that AH is equal to 15. So you see now you have actual dimensions now. This is actually 15. And ED is actually 12. Which makes sense because the ratio is like 12 to 8. Which is like 3 to 2. Yeah. And then it says calculate the length of EK. So EK is this small line here. So I think with the EK, we have to be careful here because hey, if you're gonna get EK right, you need to get as many ratios as you can on the right side here, on the far right. Like we have to be careful because I mean, like, let's look at what we have here. If you look at, there's no EK anywhere here. You know, there's no EK anywhere here. So EK is just as a result of, you know, creative thinking. But without thinking too creatively, we should not forget what we have just proven. Because what you have just proven, 99.99% of the time, is going to help you in like the follow-up questions and all that. So let's see what we can do here. This AH, let me put it in blue. No. I shouldn't put it. Wait, the good news, let me put the 15 in blue. Oh, excuse me. Put the 15 in blue and this in pink. Because the EK, you see here, the 15 is representing, it's helping us with one of our ratios. So let's just get the actual figures of what we have. So here we already know that AH Oh, yeah, we already know that AG, or rather AH, we know that AH over HK has, it's split up in the ratio 3 to 2, right? So what we now know is, in terms of actual dimensions, on the left here, AH is like 15. So you can put 15 here, and then the HK part, we can leave it out, and then work out HK. So cross multiplying, you're going to have 3HK equal to 30, which is going to be equal to HK is equal to 10. So now you have HK as 10, you know. So you have more information now. HK, this thing here is 10. This thing here is like 12, and then that thing there is like 15. Yeah, so it's definitely still a bit messy. So your best bet here is to get also, let's see, the AE over the ED. Yeah, let's get AE over the ED there. So AE over ED, AE over ED, which is for the pink lines, we worked out that ratio to also be 3 over 2. But we have dimensions now. ED is a 12. So that can be there. AE is there. And then multiply by 12 on both sides. There's like AE here. There's like 36. No. Yeah, no, definitely. Multiply by 12 on both sides. It's 36 over 2, which is like 18. That doesn't sound very normal. Really? Oh, yeah, no, it sounds fine because it's like a bit longer, that one. So let's just maybe give it its own color. So let's see here. The whole thing here, AE, is 18. So you can already see from here, it doesn't look like, can we then work out EK? Yeah, maybe, almost. Can we? Because it's like 18. From here to there, it's like 10. Yo. Yeah, it's crazy. Wait. 12 plus the 18 is the whole line, right? And then, oh, I feel like I'm like about to like, I feel like we're close, but then at the same time, it's like, ugh, this is like so messy. It's like, yo, why is it like this now? Let's see what else we can do here. This is like 12. This is like 10, and then this is like 15. You're not. Come on, bro. Come on. Oh, wait. We can get the EH here. Just basic arithmetic, bruh. Come on now. Because it's like 18, right? Minus the 15 gives you a 3. So this dimension here is just a 3. So now we use like a small thing there. That's just a 3. And if this is a 3, it means that this is a 7. You know? It's just basic arithmetic. So from what we have, so from the 5 marks, right? You can imagine the 5 marks came from this. We definitely had to get that, of which we did. This we definitely had to get that, of which we did. And then the moment we were able to like put those in our sketch, we were able to now say HE, here we can write it out. HE is equal to AE minus AH. You see, that's like 18 minus 15, which is a 3. And then here we can say, therefore, EK is equal to HK, which is the whole line there, minus HE, of which here the EK that we need is just going to be equal to 10 minus 3, which is a 7. Oh my goodness, this feels like so amazing. Yeah, so that's the idea with this kind of equation, you know. I mean, like at face value, it looks like it's a monster, but I mean, to be honest, just going through it, it's like, I guess we are vibing with Euclidean geometry, like vibing hard. But anyways, let's move on to the next question. The good news is you can always, like, go back and see what we did. So I think, to be honest, the highlighting the blue parts and the pink parts, that helped like a lot. So let's move on to question number 10 though. Question number 10. Well, this sketch doesn't look so bad. Is it the last question? Oh no, we're not. Hey, you're not. Yeah, this paper is long. I don't lie. This one is like long. Question 10 says, in the diagram, W is a point on the circle. W is a point on the circle. With center O. V is a point on OW. Okay. So this is equal to 90 degrees because these are equal. And then it says here, chord MN is drawn such that MV is equal to VN. So you have MV, right? Where is MV? MV is like there, and it is equal to VN. Fine, perfect. And then it says the tangent at W meets OM produced at T. Yes. What? The tangent. Oh, we have a tangent here. The tangent is TS. Okay. I literally just read and I was like, what? What? Yes, master. So there's a tangent here now. I might as well make that a straight line, bruh. Like, why have to make it so crooked? Let's just do our best. There we go. Perfect. So let's stretch this a bit like that. No. Come on, bro. Come on. Boom. So anyways, the tangent, it says here, the tangent at W meets OM produced at T, and then it says here, and ON produced at S. Okay, fine. They're just describing the sketch, right? And they have like really dumb ways of describing the sketches, right? Yeah, ne? But for 1 mark, they said, why is OV perpendicular to ON? Because of the line from center of circle. So you can just say line from center of circle bisects chord. So because it's like bisecting this chord, it means that it's cutting it at an angle of 90 degrees. So for 2 marks, this is what we need to do. It says, prove that MN is parallel to TS. Where is MN? MN, there's N, there's M. We need to prove that it is parallel to TS. So proving that they're parallel, we can just show that these are both equal to 90. Of which showing that OWS is 90. That's just another theorem. So OWN, right? No, OWS. OWS is equal to 90 degrees because tangent perpendicular radius. So therefore, MN is parallel to TS. The reason is corresponding angles are equal. Corresponding angles are equal. Because we have spotted corresponding angles that are equal. So it means that those lines are parallel to each other. And then it says, prove that TMNS is a cyclic quadrilateral. Well, proving that something is a cyclic quadrilateral, there are 3 ways to do that. Of which the 3 ways, it depends on the sketch. You're either gonna work with an exterior angle for you're gonna either prove that the exterior angle is equal to the opposite interior angle, or you're going to prove that opposite angles add up to 180, or you're going to prove that you have angles in the same segment that are equal. So here it looks like we may have to work on the what you call exterior angle of a cyclic quad approach. I think that might work because what we already know is that firstly, this is equal to that because these are corresponding angles. This is equal to that because those are also corresponding angles. but then these are equal to each other because of, you know, base angles of an isosceles triangle. So let's just write out what we're going to do here. We want to prove that this angle M1 is equal to S, because if this would be an exterior angle for cyclic quadrilateral, this would be the opposite interior angle. So that's what we're going to do. So let us just maybe crop out this image so that we don't have to keep scrolling up, down, left, right, you know, I have to do that. So let's just do this, paste, crop, let's do this, oopsie, let's do this, do that, there we go, make this bigger. Okay, so what we said was we were going to, so the first thing is we can just show that OM is equal to ON, red eye. You see, so we have shown that these are equal. Let's mark it in yellow. You see, we've shown that these are equal. Now we can just show that, yeah, no. We have to show that M1 is equal to N1. The reason is angles opposite equal sides. You see, now we have to show that N1 is equal to S. The reason is corresponding angles. You see, so S and M1 are both equal to N1. You see, so it means they're equal to each other. So here, therefore, M1 is equal to S. It's more of a conclusion. So now we can say, therefore, TMNS is a cyclic quad. The reason is exterior angle of a cyclic, come on, bro. Cyclic quad is equal to the opposite interior angle. You see, that's what we have shown. We have shown that an exterior angle out there is equal to the opposite interior angle in there. And that's worth, I think, 3 marks. Okay, he's good. So for 5 marks now, oh, okay, we need to prove this proportionality expression. Interesting. So proving that proportionality expression, I don't think it's going to be too difficult, because as you have seen with these kinds of questions, or with math in general, we have seen that the question they would have asked you before is the question that's going to help you answer the follow-up question. So already now we know this is a cyclic quad, so I think that should help us in some way. So here, whatever lines they're talking about here, I mean, just because of the way it's set up, you want to think of the proportionality theorem. So here they're talking about O, S, and M, N, and then they're talking about O, N, and W, S. Yeah? That's like, oh, but then they spoke of double ON. Where is ON? ON, double of that. Wait, ON is the same as like OM. So when we see double ON here, we should be thinking of OM as well, because I mean, like, it's the same length. So let's, okay, let me just, yeah, I feel like I need a clear image. But then let's put colors in this picture to see which triangles we're dealing with, because we need to prove that 2 triangles are similar, and then we can come up with this. So let's think OS is this long line here. Now, if you think of it, if you're going to talk about this long line is in this triangle or this triangle. But then the bigger one is not practical because it's too big, you know, or rather, we won't have something to prove it to be similar to. So our best bet is, if for this long line here, we might as well think to ourselves that we're going to be talking about O, W, S. You see, reason being, if you're going to be talking about OWS, if they have just mentioned OS, it makes sense because there's already an OS here, there's already a WS over there. So our first triangle is definitely going to be the red one there. Let's see what other lines they're talking about. They're talking about MN here. MN is this line over here, the long one. It's a whole long line here. Woo, okay, yeah, I'm starting to think of the long line again. I mean the big triangle again, but actually let's see. So this is MN, right? The issue with MN is that MN is two parts of one line that is equal to each other. But let's see, they spoke of MN here, and then they also spoke of ON again. No, not again. They spoke of ON. Fine, they spoke of ON, and then they spoke of WS as we already spoke, as we already said. So the issue with us thinking of MN as a whole is that this would be the other triangle we'd be talking about, but that is not practical, you know. So what you would want to think to yourself is, for this kind of equation, it's best if we maybe just focus on 1/2 of MN, because 1/2 of MN allows us to at least work with this triangle, of which working with 1/2 of MN is fine, because whatever VN is, if we double it, it will just be whatever MN is. So we would not want to overthink in the beginning. In the beginning, your task should be to think to yourself, okay, which two triangles can I work with and prove similarity first, and then try to end up with an expression like this. And ending up with an expression like this, it doesn't seem like it's gonna be too much of a mission, because why now? Well, because we have lines here that are many lines that are equal to each other, and I keep putting this. I should have put two of them here. But yeah, let's see what we can end up with here. Let's see what we can end up with. But then the other thing also is, with just having to have like scene, I'm also even considering, but then what about the big triangle? Because hey, let me actually even copy this image and paste it again and show that, hey, maybe the other image is the one we should work with, because I'm also looking at how they spoke of ON, right? I mean OS. But then I mean, but then still though, incorporating OT and TS, yeah, I think that's gonna be a mess. So let's just leave that and go with our gut with this one for now. I mean, if it doesn't work out, we can always, like, go back. So let's see what we can do. So here OVN, or let's rather call it ONV. So triangle ONV, and triangle OSV. OSW. What we already know is that these we proved to be equal. So O2 is the only thing left. So here we can say O2 is equal to O2 common angle. And then here, the rest, what is this one now? OVN is equal to OWS, proven. And then ONV is equal to OSW. The reason is also proven. And then from that, what now? We can then say, therefore these are similar. Therefore, ONV is similar to triangle OSW. So from having to have said that, now we can write out things like ON over OS is equal to NV over SW, which is equal to OV over OW. Perfect. So now from here, now we can work with our expression and ask ourselves. So here they spoke of OS, right? Where is OS here? There's OS there. They spoke of MN. There's no MN anywhere. But then VN twice is going to give us MN. And then here they spoke of ON. So there's ON over there. Perfect. And then SW. Perfect. You see? So from these three, it looks like only these these two are going to help us. So we can write them out, we can single them out, and then give a reason for writing them, which is just the proportionality theorem. Or we could have just given the reason here immediately, and then the next step we would not need to be writing this. So now we just have to think strategically, you know, because now look, I mean, if you cross multiply so far, let's see what happens if you cross multiply. If you cross multiply, you're gonna have let's see, let's have OS and the NV on this side equal to ON times SW. And then from here now we need to look at what we're trying to prove. So far we have OS and then we have NV. NV is half of MN. So that's what we can do. We can change it to half of MN. The reason we're changing it to half of MN is so that we can at least have MN in our expression. And then from here, it looks like we're home free because, I mean, like, this is where the creativity comes in, as we said. Or we've already showed our creativity, you see. Because now we can just think to ourselves, let's divide by a half on both sides. So dividing by a half on both sides, this divided by a half, this divided by a half. You're going to have OS times MN here. Here you have a 1 in front, you see. So 1 divided by a half, that's just a 2. And then here you can just write it as WS, you know, because that's how they wrote it over there. And then we are done. Like, oh my goodness, this is like so amazing. Yeah, I feel like this paper started out chilled, but then the Euclidean part, you like, hey. But then I've been working on Euclidean for some time now. So I think that's why, you know, things are just flowing here. But anyways, let's move on to question number 11 and, like, you know, call it a day because yeah, why not? We are at question number 11, the last question. Like, yeah, it says in the diagram, what is the yeah for now? It says in the diagram, KM and, wait, we have KM, MN, and KN. They are drawn in the circle with center O. I feel like we're going to be asked to prove the ten-chord theorem here. And then it says PNQ is a tangent to the circle at N. Prove the theorem that states that M and Q is equal to K. So we need to prove that this angle is equal to that angle. Okay. So, I mean, like, proof of the ten-chord theorem is there on the main channel. You know, if you search on YouTube, Bright Young Brains, you go to the main channel. Or you can just, yeah, I mean, like, yeah, the main channel is Bright Young Brains. So with the idea is that, what is the idea now? The idea is that we need to keep in mind that with this proof, it's all about the construction. You know, you have to construct a diameter first. So let's say here, construct diameter. Oh no, you're kidding me. So little space. Bugger, man. This is like, what is going on? Hey, let's answer the question starting from up here. Let's see. Construct. Come on, man. Construct diameter. Which diameter must you construct now? Construct diameter. Let's label it N O, and then let's think of a random letter now. A is random compared to what's here. We're gonna name it N O A. And then this diameter, you always have to make sure that the other line always goes to the angle you're working with. You see, make sure your line goes to the angle you are working with. So you've constructed that diameter A or N, and line AK, you see. So you also want to draw line AK. There you go. So the reason for doing this is you want to make use of 3 theorems to help you. The first theorem, it's actually just, 3 theorems to help you prove the ten-chord theorem. The first theorem to help you prove the ten-chord theorem is the tangent perpendicular radius theorem, because that's gonna be able to tell you that this is 90 degrees. Secondly, you're gonna use the angle in semicircle theorem to show that this angle here is 90 degrees. Lastly, you are going to use the angles and semi-angles in the same segment theorem. Yo, what just happened there, bro? The angles in the same segment theorem is going to help you to show that this angle here is equal to that angle over there. 3 theorems to prove 1 theorem. That's how you know the 10 chord theorem is a boss. So anyways, let's see. So from here, it doesn't matter which one you use first, you know, as long as you can just label your sketch first, you'll be good to go. So here, just name it accordingly. So here you can name it N1, N2, and then this you can just name it K1 and K2. So that's all based on your construction. So according to your construction, you have to state these. You have to just state that A and Q is 90 degrees because of the 10 because of the tangent perpendicular radius. So here let me put that up there, put that up there, put that up there in the Hall of Fame. So I feel like this sketch should not have been so big, but anyways, let's say here A and Q is equal to 90 degrees. The reason is tangent perpendicular radius. The next thing is AKN is also equal to 90 degrees angle in semicircle. Lastly, N1 is equal to K1. The reason is angles in the same segment. You see, this thing is all rigged because you've just used 3 theorems to prove 1 theorem, you know. So with all these 3 things being mentioned, it's all just algebra now, because all you now need to say is you know that, remember, A and Q is 90, right, which is the whole thing. So here you can say, therefore, where do I write it? Let me write it down here. Let me actually move this lower so that I can see it somewhere there. Yeah, somewhere there. So with all this that we have written out, right, let's start with the top statement. According to the top statement, right, here we can then say, therefore, well, look, A and Q is N1 plus N2, you know, that's based on our construction. So here, A and Q is equal to N1 plus N2, you see, because of our construction, you see. So from here we can put numbers now. This is 90, N1, we know it is just N1, and then you want to isolate N1 here, you see, or rather no, you want to isolate N2 rather. So N2 is 90 minus N1, and then you leave it, and then you do the same for the AKN. So AKN is equal to K1 plus K2. The reason there is our construction. And then from there, you do the same thing. Here, you know, this was 90, K1, K2. You want to isolate K2 as 8. So this is 90 minus K1. This is equal to K2. And then remember we said K1 is equal to N1. So you can say, but N1 is equal to K1. No, let's say but. Yeah, but N1 is equal to K1. Therefore, it technically means that N2 is equal to K2. You see, therefore M and Q is equal to K. You see, because that's M and Q is like N2, and then the angle K here is just being represented by K2. And that's how you prove the 10 chord theorem. Nothing crazy, nothing major, because you have shown that they are both equal to the same thing, you see. the 90 minus this, 90 minus this, but then these are the exact same value. So it means that these are equal to each other. And then this is that, this is that. Let us move on. Let us move on. So moving on, right? It says in the diagram, BC is the diameter of the circle. So as long as BC is the diameter of a circle, this is automatically 90 degrees, you see. So don't leave that information hanging. And then it says the tangent at point D on the circle meets CB produced at A. To E. What? Yeah. So there's this line here. This is perpendicular to AC. I mean, EA is perpendicular to AC, and then it says here BD is a line that they drew there, and then they say let C equal to X. Interesting. So anyways, here it says give a reason why D3 is equal to 90. Wow. Angle in semicircle, bro. Angle in semicircle. And then it says here, for 1 mark, A, B, D, E. You have to prove that it's a cyclic quadrilateral. Give a reason why A, B, D, E is a cyclic quad. So let's see. A, B, D, E. A, B, D, E. Well, cyclic quad, fortunately, this is 90, right? And we know that this is 90 also. So this is an exterior angle of a cyclic quadrilateral. So D3 is equal to angle A. D3, table man. D3 is equal to angle A, right? Exterior. These are both equal to 90. Right, these are both equal to 90. Therefore, A, B, D, E is a cyclic quad because an exterior angle is equal to the opposite interior angle. There we go. D2 is equal to X. We have to prove that D2 is equal to X. Where is D2 now? D2, where are you? What? Really? D2, yo, let's use the different color here. D2, we have to prove that it is equal to X. So remember, if you cannot prove that something is equal to something directly using like a theorem or a formula, what you need to then do is look for something that they are both individually equal to, and then take it from there. So here we have to prove that D2 is equal to X, right? Yeah, so don't just try and look for a theorem that goes from you showing that this is equal to that, because that's not going to work. You want to look for something that this is equal to, and you want to look for something that this is equal to. Now, something that's equal to D2. That's well, we saw that they told us that we have a cyclic quadrilateral there. So yeah, I think we could, make use of that kind of information. Oh, excuse me. Wow, the boy is like yassi. Well, if this is 90, right, it means that D1 and D2 is also equal to 90. Like it just has to be, And then, wait, did you say AD is a tangent? Yes. So we have a 10 chord theorem. How? I was busy saying don't look for a theorem directly here, but we have the 10 chord theorem. Wow. Wow, Levi. Wow, bro. Wow. Yeah. So sometimes if you can spot a theorem directly, by all means, So here 10 chord theorem. 10 chord theorem. That's why they're equal. Oh, yeah, because they're asking us for a reason why, Give a reason why. Here we gave a reason why. Here we're supposed to prove that AD is equal to AE for 3 marks. AD and AE. That's interesting. AD and AE. Well, the best way is to show that this angle here is equal to that angle. Like if you can do that, then you're home free, So we say that this is also equal to X, right? Because this is X. Yo, come on, bro, think creatively. Oh yeah, so this is like x plus 90. This is like an exterior angle of a triangle, because here you have E, D, and then you have A up here, right? There's A up here, and then this line stretches like that. So you have to remember this angle is 90 plus x. So this is like 90 plus x. So this angle here is equal to this part plus this part. Excuse me. So now what now? Oh, wait a minute. Oh no, never mind. Thought I was having an aha moment. But nope. No aha moment here. It's like, no, bro. Ain't no aha moment here. Oh, wait. This part here is equal to that part. So yeah. I think we got it. I think we got it because what now? You're nah, dude. Okay, let's get D1 first. D1. I mean, like, if you think of it bluntly, right? Let me just maybe crop out my image here and then take it down there, because I feel like we are onto something here. You know, this brain has been working overtime, so it's like it's literally like in wherever it is, maybe in flow, whatever. But hey, it's going down here. It's going down. It's very much going down. So so here, let me just paste this thing here. Make this smaller. So if you look at what we have, hey, come on, bro, come on now. If you look at what we have here, now we're trying to prove that this angle is equal to this angle. So let's start with D1. D1, we know it's equal to 180 degrees minus 90 minus x, you see? So 180 degrees minus 90 minus x. So this is just 90 minus x. That's what D1 is. Now for E, we have to also show that it's 90 minus x. And the easiest way to do it is, remember, E is equal to B1. B1 is equal to E, because exterior angle of a cyclic quad. I mean, yeah, exterior angle of a cyclic quadrilateral. B1 is equal to E there because of exterior angle of a cyclic quadrilateral. So this angle is equal to that angle over there. We are know it. So what we're now saying, okay, what we have to give it is an exterior angle of cyclic quad. So with that being said, I mean, the next best thing is to just show that this is 90 minus x, because here you see B1 is equal to 180 degrees minus this 90 minus this x, which is just 90 minus x. So here we can say, therefore, E1 is also equal to 90 minus x. You see, because I mean, like, it's equal to B1. No, E rather. E is equal to 90 minus x. So here we can say, therefore, D1 is equal to E, because they're both equal to 90 minus x. So here's a conclusion, therefore, AD is equal to AE. See, sides opposite equal angles. Whew, is good. How? Same thing again. I feel like I did this twice already. Like, wow, bro, come on now. Come on now. We did 11.2 already, bro. Come on. So I might as well use this space for like this question. We need to prove for 3 marks that ADB is similar to ACD. So any question on similarity, I'm like, it's just 3 marks, bro. Like any question on similarity always get the marks, because the question itself already gives you the marks. I mean, the question itself already gives you the answers. So let's see what they're talking about here. They are talking about ADB. So let's see where ADB is. ADB, that's this line here. Let's make this a bit bigger, bro. Come on now. Hi, woman. Sure. Let's make this bigger. ADB, this, and ACD. So ACD is what? ACD, ACD, right? That's this one. So the fortunate thing is, I mean, we already have a common angle there, and we have both of them equal to x. So I'm like, our job is done already, because we only just need two pairs that are equal. The third ones are automatically equal because of interior angles of a triangle. So here in our two triangles, we already know that A2 is equal to A2, common angle. And then we know that D2 is equal to, what angle was this one now? It was angle C. D2 is equal to C, which is equal to X, proven. Therefore, we know that for the last angle, excuse me, which is going to be D2 for the one triangle and ADC for the other one, these are equal to each other because of interior angles of a triangle. And therefore, triangle ADB is similar to triangle ACD. Whew. The reason is angle, angle, angle. We've proven that three angles are equal to each other. So yeah, man, it's good. Now we are about to work out the last two questions. This feels so satisfying. Like, it's so amazing. But anyways, let's see. It is given that BC is equal to 2A. No, BC is equal to double AB, which is equal to 2R. Okay, that's weird, but hi, mathematics. Hi, mathematics. Sometimes it's just like, what? What? What do you even want that information for? Hmm? What are you going to do with it? But let's see. So here, what do I need here? It says here, given that BC, okay, BC is the diameter. Perfect. It is double of AB. Okay, fine. So it means that this would be equal to that, would be equal to that. So that's why, okay, yeah. So it's the radius. They just mean R, R, R. They said they proved that AD squared is equal to 3R squared. Where's AD? AD is this line over here. Oh, yeah, I feel like doing some Pythagoras. Am I thinking of Pythagoras here? I'm already thinking of some Pythagoras stuff because, I mean, like, AE is the same as AD anyway. So we could use the line AE and the line AC. But then now EC now, we're not going to have anything for EC. But then this is just a 2-mark question, you know? I think anything that's like a 2-mark question, like, there's no need to like spend a gang load of time on it, like legit, you know? So for this 2-mark question, like, I'm literally looking at it and I'm like, what? Hey, hey, hey. So AB is R basically, because here they say 2AB is equal to 2R. And then here AD squared is equal to 3R squared. Well, what? Aye. Well, that's what is the previous things they asked us to prove. They asked us to prove similarity. So how does similarity have anything to do with this now? Oh, these are proportional to each other, like the big line here and the long line here and the line there. Oh yeah, proportionality theorem. Yeah, so I think you saw what I did there. You know, when things started to get a bit shaky, I just asked myself, what is the previous thing we just did? We just proved similarity. So as long as we have just proven similarity, I mean, like, we might as well write down those weird ratio things so that they can help us, you know? Like, might as well, you know, we didn't do all that work for nothing. We must use it. So here, AD over what you call AC is equal to DB over CD, which is equal to AB over AD. And then from here, we know that the reason here is just proportionality theorem. You see. So from there, we know that what do we need? We need A, D some way, somehow. So let's see what we can do here. Wait, we have something for A, B, and B, C. So let's might as well take this thing and this thing. Where is AC? AC is the whole thing here, which is just 3R anyway. So AD, we don't have anything for it, so we can just leave it open. So let's say here AD over AC is equal to AB over AD. You see? So AD here, we don't have anything for it, so let's leave it. AC, however, is 3R. You see? 1, 2, 3. And then here AB is just, where's AB? AB is just 1R. You see? Because look, 2AB is equal to 2R. So it means that AB is equal to R. You see? So, yeah. Then they said that they told us that BC is equal to 2AB. You see? So BC is equal to 2 times R, you know? That's how we were able to get all this here. Because BC is 2AB, but AB is R. You know, I think you get it. So here AB is just R, AD we don't have. If you cross multiply, you're gonna have AD squared equal to 3R squared. Kablamo, kaching, 3 marks. Anything that starts with the hands needs you to use the previous question. They say it now for 4 marks. Hence prove that triangle ADE is equilateral for 4 marks. ADE, where's ADE now? ADE. So we need to prove that this angle is also equal to the 90 minus whatever. Yeah, I feel like, should I copy the picture again? Hey, paste. No. Well, it's the last question, so let's just hope they made it 4 marks, just because, you know, they are maybe trying to just trying to make the paper out of 1/5 or something. So we need to prove that all these 3 angles are equal. We need to prove that this last angle is also equal to 90 minus x, and then we're home free. Wait, let me do this. There we go. So how are we gonna do that now? But they said hence. You know, the problem with the question that starts with hence, it forces you to use the previous question, like literally forces you, even if you didn't want to. But then so far, I mean, from our sketch, right, what we have identified is that, like, there's so many R's here. This is like halfway now. So this way said it's R, this is R, this is R. Technically, we have identified that this is like 2R, and we have identified that this is like 2R. You know, and then they said here, what did we get here? D or AD squared. Where is AD? Wait, no. AD squared is 3. No. What did I just? Dude, I'm making a mistake here. AD squared. Let's start from the AD squared is equal to 3R squared. So what now? Hi. Square rooting both sides, you're gonna have AD equal to square root of 3R. Yeah, and then what? And then what, my bro? And then what, my bro? Like, what are you going to do? What will you is do? Yeah, it's the last question, but yeah, this brain is like fried, like proper fried, you know, like fried what is fried? That's nice, like fried chicken. Hi, but either way, we are almost done. Let's see. I feel like the hands part is really the problem, because it's like hands prove that triangle, this is equilateral ADE. Let me make sure I'm even thinking of the correct triangle here. I might even be pointing at the wrong thing. ADE equilateral. So this, we have to show that it is We have to show that, okay, let's work in terms of angles. But then why are we talking in terms of angles when we were just dealing with lines right now? Like, that is weird, man. Like, it is just so weird. Like, legit. Like, seriously, it's like so annoying, you know? It's like so annoying, Joe. It's annoying. But then either way, exterior angle of a cyclic, no, exterior angle of a triangle thing. If we think of this here, this is 90 plus x. So we can easily show that this is 90 plus x. Because, I mean, like 180 degrees minus this leaves you with this. Hey, but then is that gonna work though? Huh? Is that gonna work though? Like, I feel like, let's see what I did for this one. 90 minus x, really? Yeah, this is 90 minus x, this is 90 minus x. So 180 minus both of them, it's gonna give you what now? 180. It's gonna give you like, hey, I think the hands part is genuinely like the part where I'm like, what? Why is it even starting with the hands? You know, like you could have started with anything, but you just had to start with the hands. Well, I think the whole hands part. Now, let's try and just use what we got. Remember, they gave us lengths anyway, so we might as well use them. Now, the one thing I'm seeing is, I mean, if you look nicely, right, we have a right angled triangle now. And this right angled triangle, we know that this is like 3r, square root of 3r, like we said. Because this is square root of 3r, so this will also be square root of 3r. Because, I mean, like, you know, what do we know? We know they're equal to each other. So here, so far, if you use Pythagoras theorem, right, you have EC squared is equal to AE squared plus AC squared. AE is like square root of 3r squared. AC is like 3r squared, the whole thing, and then EC squared. Then here we have like square root of 3 squared is like a 3, then r squared. 3 squared is like a 9, and then here we have like 3 plus 9 is like 12. And then square root both sides, you have EC equal to square root of 12r. Okay. I mean, like if you do simplify this, right, in your calculator will give you 2 square root of 3r. That's EC. So that's what EC is. EC is double of AD. Okay. EC is double of AD. So now what? Yeah. That's kind of the tricky situation here. Because now I'm thinking to myself, do we have DC? Hey, do we have anything for DC, Mara? We could get it, couldn't we? I'm pretty sure we can, bruh. I'm pretty sure we don't we have something for DC, Nana? Well, we have this. We have something for BD. BD. Hi, no man. This thing is just crazy, man. I think we kind of need to get something for this for BC as well. But then how are we gonna bypass the whole BD issue? Ah, come on, man. BD. Huh? What a wow, man. This is just so messy, you know? It's just so messy. It's just so messy, bro. Like, yes, man. I feel like the only thing we can go back to is what? Is our, let's see here. What did we have in the beginning here? We have AD over over what? Over AC, and then yeah, let's go back here, see what we can come up with. So from here, let's pause here for now. Cannot do anything here. So yeah, I think luckily this is like literally at the end. So I mean, like if this question is in the exam is like one of those that are just like, hey, no, then at least you'd have done most of what you can, So in the from the top here, we have these two. This incorporates BD and CD. So let's see what we can do with those. Let's do this. Stroke, remove, remove. Come on now. I feel like I'm being extra here. Okay, fine, perfect. So here, AD, where is AD? AD, we already know it's like square root of 3R over AC. AC, we already know it's like 3R. And then this is like DB, CD. Perfect. So with that being said, I mean, like the best we can do here is if we now like, let's say, what can we do now? What can we do? Well, let's cross multiply and see what we get, so that we have less variables to like deal with and stuff. So for us to get less variables from here, if you cross multiply, you're gonna end up with like square root of 3R CD and then 3R DB. So what's our issue, Velevel? Our issue is our issue is the DC here. The DC is what's boring us. Like the DC is what's killing us, like legit, the DC is what's killing us. But then, come on, bro. Yeah, it's not working. Okay, it's almost working, but it's like not working, but it's like working, but it's like not working. BD. Where's the thing now? Down here. Pythagoras theorem. Yeah. Let's see what we can do from this. So from here, it looks like if you perform Pythagoras theorem here, right? Let's see what we end up with. BC squared is equal to BD squared plus DC squared, right? The BC part, we know it's just 2R squared, so that's going to be 4R squared. And then, well, let's not skip steps. Let's just write it out nicely so that everyone can see. 2R, the whole thing squared. What do we need here? This is supposed to be BD, bro. BD, we don't have anything, so we're going to leave it as BD. But then now we can at least replace one of these variables with something up here. So let's replace, let's isolate BD so we can throw it in there. So let's do that. Do this. Do that. So here let's isolate BD, because if you can throw something for BD here, we'll only have DC to deal with. So here, let's see, square root of 3RCD over 3R. And the R's will cancel each other out, because that's just how it is for now. Will they? Well, they kind of have to, because here, here they do cancel each other out anyways. You see, because it's like an R over R there. So this will cancel out. So, if we didn't do it up here, we can always just do it here. So that this is what DB is. And then we're going to have to throw it in here. We're going to have to throw it in there. So throwing it in here, we're going to have 4R squared equal to square root of 3CD over 3, the whole thing squared, plus, remember, CD and DC is same thing. So here, this is like 4R squared equal to, this squared is going to be a 3, CD squared over 3 squared is going to be a 9. That's the CD there. Oh, that's also squared. And then these are like terms. So this plus 1 is going to give you, let's see, 3 over 9 plus 1. That's like 4 over 3. Yo. Hey. Mathematics. Mathematics will kill you. 4 over 3 CD squared. This is like 4R squared. And then from here, if you want to work out CD on its own, you have to divide by 4 over 3 on both sides. So CD squared, or CD rather, is going to be equal to 4R squared over 4 over 3. So what does this give you now? That's just going to be 3R squared. That's what CD is. Yeah, CD squared. Of which, if you square it both sides, you're going to have CD is square root of 3R. Wow. This is the dumbest last question I've ever seen, because it's like so unnecessary. Like, yo, it's like so unnecessary, and there's no way they would have just made this 4 marks. They only made it 4 marks because they couldn't make it more. So it's not a coincidence that this is like right at the end, because like, look now, remember we said that EC is this, all right? And now we have CD. So if you look at our image, CD is something we already have now, you know? So we can now just say EC. If you remove CD, you have the ED there. So we already know. So ED, you know, it's equal to EC minus CD, which is going to be 2 with square root of 3R there minus square root of 3R. This is just going to be square root of 3R, which is ED. So we've proven that all of these sides are equal to each other, you see, because if you check here, you see this is square root of 3R, this is also square root of 3R, because they are equal to each other, and this is also going to be square root of 3R. Therefore this shape is a equilateral triangle, you see. Therefore triangle A, what did they say, ADE? Yeah, they say, what do they call it? ADE. They called it ADE. Yeah, it's an equilateral triangle. Therefore triangle ADE is an how would you write equilateral now? Equilateral triangle. There you go. Yeah, so this paper was, it was interesting towards the end. But then the one thing I do recommend is the online courses. You see, the online courses dive deep into what we've been looking at. So the link to that is in the description. And obviously, if you need anything, you can just hit me up on IG. From my side, like, yo, yeah, I can smooth. This is actually the main channel, Right Young Brains, where you're gonna get like, you know, the main tutorials, short tutorials on like the different topics and all that shandy, so that you can like stay on track with your syllabus. So do not forget to check this out on YouTube. Is the other channel, was the main one. From my side, I will catch you on the next video. Don't forget to share this with your friend. I mean, like, let your people know, you know, you must plug them, so that at the end of the year, y'all can just both, all of you can like pass as a squad, you know. It's nice when you pass as a squad. But anyways, it's cool. Cheers.